There's only two of them.
Oh no, I know. Just for the Wi-Fi, for the presenting, for the speakers.
Not the same direction. Neat.
Cool. And what's the network name again?
It's one of these slides.
Peru.
There you go.
Peru pin.
Oh, low battery.
Cool. There you go.
Test 1 2. Test 1 2. Test. It works. Yeah, I think it's time to tell people we're going to start. Thank you for showing up on time, everybody. I actually really appreciate that. Thank you very much for that. I think next year maybe we'll take a slightly different approach to it and we'll just start, and if you aren't there, well, stream it. So while you already have your phones out inputting the Wi-Fi password again, you might as well just put that on vibrate.
Yeah, he's plugged in his laptop. Okay. Yeah, I think this is a very different laptop than the one that we set up earlier. Yeah. Okay, I'll go crash. Oh, no, he's using
Hey, can you see the button? Hey, good morning. It just cycles, you know. Good morning, everybody, and welcome back. For those of you following along on the live stream or just tuning into the live stream, welcome to the second day of DevOps Days Vancouver 2014. I'm really glad you came back. Yeah, thanks. I'm really glad you came back. This morning I woke up and I thought, oh, right, again. Right. It's been really fun. We had a great party last night. I hope you were there. And if you weren't, well, it was really fun, and I'm glad to see that you're here and ready to start. So this morning we have another great lineup for you. And before we get to that, I'd just like to get a bit of feedback from you about how things have been going. Do you guys feel like, just a show of hands, how do you feel about the food? Hands up if you've been enjoying the food. Hands up the food is too much or not wrong somehow. Yeah, I'll talk to you later. Because I want to hear I really want to get feedback for next year, and this is important. How many of you are interested in getting in on the email list to hear about next year, or do you just want to hear? Yeah, a lot of you. Okay, so we're going to send out an email to everyone who signed up with the emails for the Pick-a-Tick tickets, and we'll include instructions there for getting on, because I think that the paper isn't working out so well. People don't want to take time to go and fill out a form on paper, and we have to type it in anyway, so actually I'd rather it if you typed it in yourself. So if you don't have your email address as part of the Pick-a-Tick ticket system, then you should probably see one of us and make sure you get your information to us so that we can get in touch with you when we're ready to go next year, when we're starting to ramp up ticket sales and things. How many of you are interested in presenting next year? A lot less of you. Yeah. But, it's actually really fun. I actually, wrote up a talk proposal, and then I realized I'm not going to have time for that. So I didn't actually submit it. But I'm actually glad I didn't, because, honestly, it was a lot worse than what we've got today. I'm really glad that we've had such high quality of proposals and talks from everybody. Thanks very much. That's worth applauding there. So this morning we've got Kelly Shkuratov, lead member of Salesforce's technical staff. Kelly originally identified herself as a dev, but she's been working on infrastructure, and she has a really interesting talk today about transforming culture inside a large organization. Kelly, you want to come on up, and we'll get this changed over.
The clicker thing.
Clicker thing. Oh, you have to plug that in.
Plug this in my thing.
Yeah, plug that into your thing.
All right. I love how many ports MacBook Airs have.
Right. It's always, you have to turn it over 3 times.
I think if you just ignore that, if you just
close that thing.
Yeah. The thing is, we need to get that on here.
Yeah, if you do play, it should work.
You think it will just go there?
PowerPoint's quick
Check
lever.
that. How do I, normally this, forward, back, maybe?
Is that working?
Oh, giving it away. And I will turn on my mic. Can you hear me? Good placement? Decent? All right, so hello, everybody. I'll probably walk around a little bit as I talk. So my name is Kelly, and you can tell from my title, this is a little bit of a joke. It's not really meant to be anything about being doomed or anything. It's sort of a comment on size and being agile. So this is a talk a bit about agility while being a large company. So really implementing great change at a large enterprise company. This is me. I'm happy because I have a cupcake. It's got cream cheese frosting, one of my favorite things. Big smile. And so, yeah, I work at Salesforce.com. I put my Twitter handle up here. I don't really tweet, so some of you who've already added me, you might be disappointed. I'm going to try to do a little bit better for that going forwards, and my LinkedIn is here as well. And so what do I do here? What do I do at Salesforce, and why am I here today? So I'm a tech lead or product owner for Puppet at Salesforce. Everybody knows what Puppet is? Probably, yeah, lots of hands. And I work in the data center automation cloud. Salesforce has a bunch of technology clouds that they use to group similar things together. So I'm one of the teams, owner of one of the teams in the data center automation cloud. And so we were responsible for the Puppet infrastructure, how the servers work, how we structure things, internal adoption, how do we drive the use of Puppet at Salesforce, how do we encourage people, and really the rollout. So we coordinated all the rollout activities, how we went to production, and what ways we did, what patterns we used, and how we kind of made change. So as you mentioned, I'm technically a dev. I came from the R&D side. I've been at Salesforce about 4 years, a little bit more. I just had my 4-year anniversary. And in that time, I did feature work for sort of a lot for release architecture. How do we release our apps? How do we get out the door? More on the dev side, in sort of a happy place where I knew a little bit less about production for a little while. Not that this isn't a happy place. And so I tend to walk around being curious, which is a little bit how I end up involved in new projects. And plus, I'm actually remote. So if anybody has questions about working remote, I know we had a little talk yesterday, one of the open sessions about global teams and how does that work. I'm a remote tech lead. All of my team is in San Francisco, and not only that, I work with people around the world on the rollout stuff and use of Puppet. So if you have any questions about that later, feel free to ask me about it. I like it a lot, and it works for us. So, oh, online stalking. So I do a lot of online stalking with people. Just a bit of a joke, but not really. So safe harbor statement, we include this in our presentations. It says, anything here that might be forward-looking is not a guarantee or that sort of thing. This is sort of a standard inclusion on Salesforce's presentations. So feel free to read it. Slides will be posted if you really want to see what it says. So a bit about Salesforce. How many people have heard of Salesforce? Yeah, perfect. Wow, it's everybody. That's excellent news. So we're about a 15-year sort of young cloud computing company, and we're still growing strong. We've been rapidly growing. We've more than doubled, I think, in number of staff since I started 4 years ago. So that's great for us. And relevant to this presentation, because it's a little bit about how we manage data centers and how we do change against them, we run our own data centers. We colo places, and so we do a lot of management that some people don't have as a problem. We put our customers' data in our safe sites. We hold government data. We run our stuff. So that's a bit what this talk is about here. And geographically diverse teams, as I said. We have support coverage all around the world, tons of great people, tons of offices, acquisitions as well. We have offices that way. So we're very diverse. And we have lots of existing in-house tools as well as Puppet and other things, other external tools as well. I'm not really here to talk too much about the tech. It's a bit more about the culture and the rollout of what we did when we rolled out Puppet. Rough idea of scale. This is, just rough numbers from Googling articles in the past 2 years about size of people. I'm not an expert on size of everyone's data centers, but sort of roughly, we're kind of in the mid-sized company, right? We're actually pretty large, tens of thousands of nodes in our production infrastructure. That's on the order of. So that's sort of the scale of the stuff that we were dealing with our rollout. Not millions of servers or million of, however many that Google has. And there's lots of people at this size and lots of people smaller. Sort of a comment on roughly what are we talking about here. And so how did I get involved in infrastructure? Well, so on the dev side, one thing that I really love is working on automation. So I thought, cool, there's this project that we formed that had to do with sort of Rundeck and SaltStack and scripted automation. And that's one of my favorite things to work on. I used to work on some of that stuff as well at my previous company at Electronic Arts. And so that was one of my favorite things. And eventually I became tech lead of that project. And I'm like, this is great. So as such, right, we wanted to add SaltStack to our tech stack. And we said, sweet, if only we could get this somewhere. What's the best way to install minions everywhere? Everybody knows SaltStack has agents. Maybe not. They have little minions. So how do we get them somewhere? Well, the obvious choice is we want to push those out with something like Puppet. This is a great idea. Sweet. This is a problem I don't necessarily have to worry about because someone else is rolling out Puppet. Awesome. So we got a little bit more to great idea. We have an engine. People want to roll out Puppet. We can give a hand here. There are things that we know and things that we can automate that helps roll out Puppet faster. This is a great idea. Theoretically, it starts off with like, yeah, we'll just put thousands of Puppet agents out there. Super easy, right? Thousands of times. Totally cool, no problem. And we'll make that part of the standard operating procedure. Easy. Yeah, I see some like, yep, no, I see some faces. So process-wise and organizationally, not quite as simple. So back to my sort of steering the Titanic. This is pretty much just taking stock and figure out where we're headed. So this is where we got started on helping move this project forward. So we joined forces with the Puppet team. We actually merged our teams, and for 8 months we worked together. That was super cool. And really, for me, I got systems engineers. It was the first time I had devs and system engineers on the same team, and that was awesome. Awesome for sharing knowledge, awesome for moving forward, awesome for the capabilities that we could do together, and it really just brought it all together. So that was wicked. And we started with something we knew. So if you're thinking, I've got a huge project, I don't know what I'm going to do here, we picked one host class that we knew. There's one personally that I knew how to run and deploy and knew a lot about, and a lot of other people knew a lot about, and we said, sweet, we're going to pick on that one. You're my guinea pig. This is great. So pick something that you think you can win is a good starting point. We weren't really trying to boil the ocean here, we were just trying to pick a sea with the same kind of fish in it and boil those fish. So, and hint, it's the app tier. When you hit salesforce.com, that's where you're going. So we picked that. It is numerous, it is awesome, and is really well understood for us, by our team. So we picked that one. Once we had a bit of a plan, helping turn into owning, they're like, that's a great idea. Well, you know, officially then, the Puppet team merged with us, and then we owned Puppet as well, as a group. And as a tech team, we got together and wrote a button that said, press for Puppet. Great, push for Puppet. This is awesome. So, you know, there's a problem here we can solve with code. Like a Staples Easy button. That was easy. So we decided it wasn't just about Puppet either, right? We sort of decided, well, we want to make sure that we're re-imaging and getting things in a good state. Like, not in a good state, but in the state that we want things to be in, right? And defining a new way of modeling hosts. While we're at it, you know, why not? This is great. Establish new workflows for people working with these hosts. You've done it this way before, but now we're going to do it this way. We're going to push changes not that way anymore, but this way. When you build a new host, we're going to build it this way. So we did a bit of work on establishing new workflows. And then while we're at it, probably the biggest win out of all of this is designing for internal contributions. We had tons of people across the company that could be writing Puppet code. But in the past, a lot of that similar work has fallen to the ops side. And really, we're sort of trying to centralize on a communication media between dev and ops where people, you know, you make it accessible to contribute. Because we were under 10 people. We can't trying to do. So then what? I was like, I'm super jazzed. Got my dev hat on, like, we've written a tool and this is great. And we have dev people, we have ops. Awesome. From the dev side, I was a little bit less familiar about the actual ops. Wading in or putting your oar in the water. So how to move forward? Where were these reliability, data center engineering, for a different thing. And especially coming from the dev side, I had how many people work at a big company. Do you guys have some of these teams? Probably. Some of you not know how many people. There's a whole slew of people I'd never met before. So that was a bit of a challenge. Right? If I asked a company of 10,000 who can say yes to this change? Hard here. So rapidly that new people are joining all the time. So it's like we need to go forward again, and we can have those discussions as we roll out, you know, and bring the new people up to speed as well. And so that was kind of really a showstopper. Every group has a different thing they're responsible for. I'm on slow and gradual, which is important. And then you get now. Changes to go out immediately. Dev teams are like, yeah, just get it all out there. This is awesome. So really, even for any given aspect of things we were discussing, depends who you ask. Everybody's responsible for something different. So getting consensus is hard at a large company. This is not Salesforce specific. This is just It is hard. So it gets you thinking a little bit, well, if nobody can say yes, can anybody really say no? So that brings me to, it's go time. We're just going to start paddling. This is great. Start steering this ship. Awesome. So what did we do? And the short answer is anything. Anything that we could that got things going. We negotiated change windows with people, and they'd be like, well, I'm not doing any work, but Frank, somebody is doing some work. You got to talk to this group, and they're doing upgrade testing, and they're doing this and that. So there was a big negotiation there. We borrowed test hosts. Sometimes people had hardware we didn't have. Like, I need to test that. And then there's like some horse trading around like, can I borrow your server? Yeah, but not today, but only if you ask so-and-so. And so we did sort of anything that we needed, actually, to get going. And especially for us that was mostly a dev team, sort of stopped writing code for a while. Or shifted, I mean, I spent days just not writing code, and actually I still do now. So a little bit of a shift for us on that. I mean, coding is probably 10% of the battle, if I had to guess. The other 90% is consensus and rollout and go forward and action plans on how you're going to do this work. It actually changed the way that I thought about development. Used to think a lot about the code. Sit there for an hour going like, how am I going to write this? Now it's like, I sit there for 10 minutes going, yeah, how am I going to operate this? How am I going to roll this out? Who do I need to ask about this? So it really changed a bit of the way that I thought about development. So that leads us to sort of onward and upward. We did diligence to the best of our abilities. A lot of those groups that I mentioned on the previous slide, they have virtual architecture teams, they have forums. We went to those forums, we talked to those people. People had concerns, we alleviated them, we addressed them, we talked about them. We did a lot of talking. And while we did that, we kept up a this is happening front. This is totally going forward. It's going to be awesome. We can totally address that problem. Or if you have a concern, we can roll out this way, and we can look at changing it after, if that is a problem, right? I mean, change is scary for some people, maybe, maybe not. You know, mostly people were actually pretty supportive, but sort of back to the consensus, this is happening. It needs to happen. We know it needs to happen, lots of people do, and everybody really did, but you know, we just kept going. And we made decisions. So some of the things about like, how often should changes go out, and how, and who, we made some decisions. We said, you know, we're gonna run Puppet at this frequency or that frequency. Patterns are gonna be done in this way. If we have a problem with the way that this goes, we can look at changing it, right? But we have a plan, what we think is reasonable, and we're gonna go forward. So if you catch yourself coming up against something similar, just make a plan, right? Put your popsicle stick in the water and start pointing in a direction. And just say, you know, we're gonna go for it. So interesting for us, actually, Salesforce has a pretty rigorous change management process. Trust is one of our #1 values, right? We care about customers. We're very careful, and internally, about other teams and trust with other teams. But at the same time, having a new project, and especially coming from the dev side as well, and not as familiar with prod rollout, led to a lot of fun times explaining my project to people I'd never met before. So how many times do people have to call someone they don't know and try to explain what they're doing? Yeah. It's like, hi, my name is Kelly. You might know me from previous projects as blah, blah, blah. And now I'm here to tell you today about Puppet. And here's what we're trying to do. And they're like, oh, no, but I'm not in today. All right, thanks. Hey, my name's Kelly. You don't know me, but, you know, and that would go on, and just sort of from person to person. And that was sort of the part of spreading the knowledge and part of me not writing code for a little while, right? Is just talking to people. So it went a pretty long way. And we had lots of new people joining, as I said. We've been growing so much. We're like, what's this Puppet thing? And what are you guys doing? It's like, well, hey, you don't know me, but. So there was a lot of that went on. And ultimately, people were supportive. And we took that button, push for Puppet, and we started pressing it. Makes sense. We pressed it a few times, and then we rolled back. We did that for a while, and then eventually it's like, well, maybe we'll leave it that way. Oh, sweet. Press, roll back, press, oh, leave it that way. And so we started pressing that button slowly and then faster. And things started to happen. So extra boost forward, or the winds were in our favor, or that kind of thing. We had a bit of success. And people were interested in that from many parts of the company, which was cool. And so instead of the gradual rollout that we had planned, so we made a plan and said we're going to roll out in this way. And then it sort of felt like you're standing at the back of a concert, you know, and you're like, I'm short, so I can't see anything. But you're trying to see over people, and you're like, where's the stage? And then all of a sudden it was like, oh, I'm pressed right against the stage. Everybody was behind me. It was totally awesome. And everybody's really propelling us forward. While you're at it, well, if you're gonna roll out anyway, as you've said you are, which, we said, well, why don't you handle these upgrades and those upgrades? And while you're at it, do this extra handful of nodes, thousands, whatever it is, right? While you're at it, yeah, totally. And we'll lump this in, we'll lump that in. You guys are gonna do all of that. So it got pretty crazy there for a little bit. Our rollout was crazy accelerated. You have a plan? That sounds good. Go, go, go. And we had awesome support from leadership. Like, well above me, people are going, yeah, this needs to happen. This is awesome. People need to get on board. Things started happening. And that was super exciting. That leads us a bit to part 4, share with others, or steering with a lot of popsicle sticks. The title is a little bit of a joke about, one person not necessarily can do anything, but a lot of people pointing the same direction, maybe. Right? That was key to this rollout. We are a large company, and our team is only a small company, or a small team. So we really need a lot of help here. Not only that, we're mostly development. We're not an operations team. We're not staffed to do all of this work all of the time, at all hours of the day. So we're going to need a lot of help. So we took our show on the road, so to speak. We flew out to Dublin. We've flown to Singapore this year. We've flown to San Francisco a bunch of times. And we started training people, and we enlisted help. I was just shocked how many people were willing to help. Even though they're busy and they're swamped, people were awesome. We went to Dublin for our very first training, and pretty much we were making sure that it was working right up until we got there, the morning of, actually, while we were there. Like, okay, I think it's going to work. And we had a couple of guys there, and we arranged this training, and we had like 4 days. And we pretty much said, well, depending what you're doing, we'll give these talks at literally any time of day. Because someone's email would go off, and then like all the guys would, oh, Urshu, gotta go, or gotta check in something. They're like, no, never mind, things are good, we're back. So we were pretty flexible about the training, which is important when you're working sort of with the ops side of people, depending what's going on. And so we said, all right, well, we're just gonna show you what we've written, show you what we're doing, and there's a button, we're gonna tell you about that button, and maybe you'll all try pressing it. This is great. And then immediately they're like, well, I got 50 running here and 50 running there, and like, oh, okay. So apparently they were really good at buttons. It's kind of the gist of what happened here. They were really good with buttons. They gave us a huge boost. And that was sort of one of the key drivers for all that support that we talked about. So these guys were awesome. People I'd never met, never really talked to, they were totally behind us. Same with Singapore. We were actually working with a bunch of guys in Singapore for months before we went out there. We had some champions, and they were also very good with buttons. They did like just tons of stuff. They're like, yep, nope, I got this and this and that, and just took real ownership of it. It was awesome. And this sort of constituted almost a virtual team. People kept calling it, the team, and I'm like, technically we're not a team, but it felt like it. It's totally different groups, different technology clouds, people not in data center automation. We're running stuff that we wrote and working with us. So people rock is really what I'm getting at here. We have lots of great people, and I really enjoy meeting them. So this quote on the top here, fix forward, break things, more puppets, came from one of my coworkers who sort of coined that phrase. What should we do in the next? We do sort of release planning on what we're going to do next. Fix forward, break things, more puppets. And the good news is nothing really broke for us. I mean, we touched a lot of infrastructure carefully, but quickly, right? I said we had that acceleration that we had, and nothing really broke. If anything did come up, just in case it was related to what we were doing, we were right there. We were ready to look into whatever it was. Even me, who didn't know a ton about some of the other stuff or the infrastructure, I was there too. And we supported what we did, and we built trust here. There was one day where an email came out that said possible performance degradation on something. It was something that we had touched. And I'm like, oh my God, I've been waiting for this day. Waiting for the day where I have to have a little bit of was it us, right? And I took that email and I printed it out and I put it up at my desk. I'm like, it's about time. If I'm getting an email where I think it could be me, it means we've done something important, we've gotten somewhere. So I was pretty excited about that. I still have it up on my desk, actually, possibly related to me. You can imagine rolling out a system that is touching files on thousands and thousands of nodes. It's a little scary, a little bit, right? Especially waiting for those emails. What if I do something that does do something? I mean, we have a lot of testing, and it's not that. But I was waiting for one day where there was a chance it could be me. And it happened, and it wasn't. But, means we've gotten somewhere. So you got to celebrate a little success like that anyway. So how it went. This is a graph from part of our rollout of things. So there's a tiny little sliver over here around our initial trials and the push and rollbacks. And right at that corner there is Dublin. We're like, yeah, we got this. Sort of our initial jump, more so, and Singapore and more help, and then different host classes. We got everywhere. And since then, even further, right? But this is just sort of a graph of our rollout. So this is us working alone. This is getting help. And lots more help. Other teams. That top chunk was done by a totally different team, actually, sort of using our tooling and working with us. So that was awesome. We thought, well, this is great. If other teams can help with the rollout, imagine if they're helping with some of the authoring. Imagine if they were helping with all the other aspects that make this hard to do as a small team. So it goes a little bit back to tech time. Finally, more code. Awesome. So I don't know if any of you guys have heard of R10K. It's a little, hey. So we started using it. It's a way to aggregate different Git repos, and basically we moved ownership of a bunch of the role-specific Git repos to other teams. You know something about this. This should be you. It shouldn't be me, especially not forever. It can't be me. So this should be you. And so we use that to start letting other people contribute. That was the real key. I mean, having some team have to wait for me to review every single change at a giant company is impossible. It's just really not going to be possible. There are changes that we review, and we do look through what's happening. But at the same time, teams are enabled. Teams are enabled to submit their changes, to do what they need to do, and to be self-sufficient and iterate themselves. And so we're really pushing things to be self-service. You know, there was a time where sort of, sometimes a bit of dev and ops in the wall, and I don't know what's out there, and is a way that people can talk to each other. And this is a way that more people are responsible for what's running. So more about sort of conversation. And then related to that, more training ensued. Lots of training still around using Git and using Puppet and writing Puppet and running our tests, and that's still ongoing. We did a lot of work sort of to improve the way that people could do that and train people. And sometimes, from the ops side, they're like, I never use Git, or I don't do a ton of development, or I'm not as familiar with this test framework or that test framework. So we were training, and this will still be a big part of what we're doing, is trying to help people be successful at contributing. It's probably the number one goal. It needs to be possible for people, and they need to get responses, and they need to be encouraged to do what they're doing. So that kind of takes me more towards what's left to do, and taking stock of how far you've come. You're like, hey, my ship turned, sweet, awesome. What's next for us? So going forward, we're looking at more development environment improvements. We use Vagrant, VirtualBox. We spin up a bunch of hosts. Some challenges still remain. Like, it's not that easy to run your whole infrastructure on your desktop necessarily at a large company. It's just not that easy. And not everybody knows everything either. It's like, well, this one host type doesn't work, or it doesn't do what I expect. How do I do that? So those conversations for us will be ongoing. As well, internally, some environments are run different ways, and we've been converting those or are working to do that. Better representation internally is still important to us. There are some fundamental differences between some of the internal environments. In many ways, production is perhaps more consistent than internal is. We have a huge internal infrastructure as well. We said we had that many production nodes. There are tons of test environments backing all of these things. Tons of infrastructure internally. It's almost a second project of the same magnitude as far as doing the operational work to update these environments. So for us, it kind of needs to spread both ways. And we need to go further internally than we have already. More host types. So we kind of had that graph around like host types that we tackled. We took all the ones that people logged into, and then we took other ones, and we changed the way that people work with those tiers of hosts. There's still some more. More work to do. If there was more work to do, I wouldn't need to be here. And more training, warming people up to it all. As a dev, maybe I don't necessarily want to know how my hosts are made. Maybe I do, maybe I don't. Or maybe I haven't had to before. So there's a lot of sort of training and teaching people and encouraging people. Has anybody heard about Chatter? It's our internal product that we have, for commenting and mentioning and having groups and having feeds. So we use this internally, and we have a big group for all of this work. And everybody who has a success, I try to post in there. Like, congratulations, so-and-so, you did such a good job, awesome working with you. Celebrate successes, that's a huge one too. So going forward, more celebrating of people's successes. It's hard for people to step up, especially from the dev side, being a dev, and wearing my dev hat. It's hard to step up because you're like, I don't know anything, or I don't know what to ask, or I don't know who to ask, or there's all these groups and I don't know who to deal with. It's hard. I had to call up network engineers and be like, hey, so we're trying to stand up these stacks of servers and I'm having this problem. And they're like, blah, 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 blah. And I'm like, no idea what you just said there, right? At least to start. And there was one day that came by and I called up our network engineer and I said, hey, is this such and such implemented in the such and such? And he's like, yeah. I'm like, wait, did what I say just make sense to you? It did. He's like, yeah. And I'm like, no way. And then he said something back, and I'm like, and that made sense to me. I'm super excited. So a little bit about celebrating people's successes here as well. There's a consensus to be reached, or a common understanding that can be there for dev people who are looking to move into ops. I mean, some people here probably are looking to know a little bit more and work more closely, and that's totally possible, is really what we're saying. And we found some interesting things. I'm getting sort of close to the end of my time here. We went through and we did some hardware upgrades where it made it easier for us to do our jobs. Hardware swaps, we helped schedule that stuff. Some lesser services were not necessarily stateless. We found a few sort of odd ducks doing a few things that we wanted to fix or that should have been fixed. And those things were fixed. People were like, yeah, totally, got it, fixed. Awesome. A few lost hosts found. In a giant infrastructure, sometimes there's a few stragglers, or just needed a little love, perhaps. It's configured a little bit from, 5 years ago, or no, stuff's more recent than that. But you get what I'm saying. A few lost hosts found, and a few areas of more siloed experience now shared on all sides, and allies in unexpected places, people I never knew, never met, working with me. Thursday night, I was up till after midnight talking to a guy on the other side of the world who I've never met, and he's running this tooling, and he's like, I'm having a problem. I'm like, I'm right there. And he tried some new things, too. It was super awesome. I celebrated his success. So I'm sure we'll find some more of this stuff, all of these things. New allies, hopefully not too many lost hosts, Yeah, and the whole experience has been super positive. And that's it.
Thanks very much, Kelly. Over at D&B Vancouver, we're going through our own transformation, so I'm looking forward to reviewing your stuff a little bit later on with the rest of my team there. Is it neat switch right here? Yep. So next up we have Jeremy Pierre, who's a senior software developer at Acuity, where he's advocating for borrowing more from the world of operations. Oh.
We can do this.
We can do this.
We can do this. We have the technology and shit.
It's exciting. You can always just put your laptop down here too, whatever works for you.
It's okay. I got lots of notes.
Okay.
We'll figure this out. Let's see if this works. Yeah, I got to. All right, can you hear me okay? All right, as Chris said, my name is Jeremy Pierre, and I'm here to talk a little bit about how to survive until you have operations, which is maybe a bit of a funny spot. Full disclosure, I am not an ops person at all. I'm a developer at a company based in Toronto called Acuity. Acuity is a retail analytics platform. Gives retailers and their vendors a consistent view of what's happening at the store level. To borrow something from my colleague Tyler, it's a little bit like Mint.com for point-of-sale systems data. So Acuity stack is comprised of a relatively large number of components, especially given our age, which is about a year and a half, roughly 2 years. Our backend is made up of a handful of services built in both Scala and Erlang. We have a couple of Spark applications to handle data ingest and some different analysis. And we have a web API built in Scala that serves our clients, both iOS and a single-page JavaScript application. The back end, it should be noted, is developed by 3 full-time developers, one of whom doubles on the iOS client. And we have no actual operations staff per se. It's just devs. I have only one disclaimer, and that is everything in this presentation is learned through pain. I have screwed everything up that I'm advocating. And I've typically screwed it up in front of very experienced operations people, which is kind of embarrassing. Mostly in front of ops maniacs like these guys in a former life. So my aim today is to try to lay out what I have found to be the fundamental principles and techniques that can help us as developers deliver some part of the success that having a great operations team brings. Hopefully I can help any other developers who are paying attention avoid similar mistakes and pain, obviously. Now, I've built this talk on 3 core premises, and I've given them in decreasing order of contentiousness, I think. The first one, and the one we might disagree the most on, but I'm right, is that applications of even moderate scale and longevity will require operations people at some point. The second is that young and small organizations, specifically software-based organizations, rarely have operations people at all. I think this is due to a variety of reasons, but chief among them, I think, is likely budget, to be perfectly frank. It should be noted that these young and small organizations often, the developers involved in them, often lack operations experience entirely as well. They're not used to having to deal with these concerns. The final one that I think we can all easily agree on is that everybody likes to have consistent and reliable environments and products. Nobody likes overtime. That last premise is actually pretty important, since in my own experience, nothing I'm advocating here requires heroics, and nothing requires you to go all in, as Kelly mentioned, boiling the ocean. You don't have to do any of that to get started with the stuff that I'm talking about. Now, in the abstract of my talk, which I don't think was actually published anywhere, but in the abstract, I mentioned this notion of trying to plant the seeds of an ops-ready culture. And I think that this word culture deserves a little bit of clarification, because at the current point in time in our industry, it's a very loaded term. We use it a lot to justify in versus out groups and to support monocultures. And so for the purpose of this particular talk, I'd like to try and limit it in terms of its scope. And just to define the early aspects of, where's my cursor? There it is. To define the early aspects of this particular thing that we call culture. Oh, there it is. Sorry. To adapt first, and maybe paraphrase the anthropologist Joseph Tainter, hopefully not to his detriment, we can define culture as an artifact of social groups. It's a byproduct of how we organize and how we communicate with one another. And in trying to, keeping that first and foremost, we can try to at least positively shape the culture that we will eventually find ourselves with. So for the purposes of this particular talk, the particular aspects of this cultural byproduct I'm most concerned with are how together we communicate, plan, and learn as a team, all of these things. And I think, just a quick side note, the way we learn the most, I think, from failure typically, but we do ourselves a disservice when we fail to leverage our successes. As Kelly was mentioning, celebrating our successes, but even going a little bit further and actually building upon those. And to me, the way we approach these particular aspects has an enormous impact on both the maturity and the professionalism of an organization's culture. So I've tried to choose a set of principles and techniques that directly impact these areas. So, to start off, we have to figure out what are the key principles that we can adopt from operations as developers. So what makes a great ops person? When developers, developers, throw our software over that proverbial wall to the wizards and mad scientists, etc. on the other side, what happens? So what goes on behind that curtain? And I would say that the single most prevalent aspect I've noticed, shared by every single great operations person I've ever met or worked with, is that they care deeply about production. That is the core central thing. And this deep concern with the welfare of production is paramount, because production, for all intents and purposes, is synonymous with your customer's experience. So in effect, production and your customer experience at the end of the day are the same thing. This relationship means that your operations team, when you have one, is often closer to your customers by way of their experience than your sales team was, than the developers building the experience are, and then even sometimes your customer support team is, even if they don't talk to those customers all the time, the ops people, I mean. So in effect, I would say that operations, a lot of the time, are the stewards of production and the customer experience. Stewards is a bit of a funny word, but I think it fits here. Back when we were building stuff like this in large feudal estates, the steward was somebody employed by a householder, ruler, or landowner to manage affairs on their behalf. So amongst other things, this included managing accounts, land, employees, what have you. To exaggerate a little bit, they sort of managed the means of production and the results on the owner's or ruler's behalf. The steward was the owner's proxy and was ultimately held to account for everything that occurred with the holdings. Now, for experienced operators in the room, this should start to sound eerily familiar. So what do we adopt from operations? And I think that these things here, communication, ownership, and preparedness, are a core set of principles that stem directly from this preoccupation with production. So communication. Well, communication, I would say, is the way we share knowledge, specifically one of the things I'm concerned with, and how we share knowledge can be seen as the root of a culture of professionalism. It's not just when your operations team comes to you and asks, hey, why did you think filling this server's disk full of logs was a good idea? It has that active form, and I've done that, and it also has some passive forms. The products of these two branches, active and passive, that I really want to focus on are, as I hinted before, knowledge transfer, but also providing visibility into the systems that we're operating. And I think that documentation is obviously a big part of this. And it's easy when we start to talk about documentation to make the criticism that developers generally do a poorer job of this than operations people do, or at least great operations people do. And I think this is, we don't often understand how necessary this is as developers because we don't emphasize, generally, repeatability and predictability to the degree that operations people often do. So before everybody gets worried and starts muttering agile under their breath and decrying hundreds of pages of specifications, I'm not advocating that particular extreme. I think that Amazon's practice of working backwards actually provides a really nice happy medium here. Werner Vogel's, is there a CTO, I think, put a great blog post out back in '06. I put a link down here and I'll share the slides, don't worry, where he details this. To summarize it a little bit, what you do is you start by creating a pseudo press release where you describe the customer's experience. You work backwards from that to some sort of even rough documentation where you describe, again, the customer's experience in slightly more detail. And then from that, you can consistently work backwards until you get to the code. At Ascuity, we've adopted this actually even for internal services. So where a customer may be little more than an API consumer or a chunk of our JavaScript application or other services consuming other services. But the key here is to keep the customer in mind, ideally the actual human customer, but still all of the ones in between, and define that experience first and foremost. And the documentation essentially writes itself when you do this. You still have the onus to keep it up to date, but it actually works pretty well. To move on, when I first started working on this talk, I actually had the term responsibility up here. And terms like responsibility and accountability in isolation is that without the associated authority to make change, these terms often amount to little more than scapegoating. So for someone to take ownership of a product, or in our case, production, they must be trusted with the authority to make some positive change in the customer's experience. This trust and authority to make change, even if you limit the scope of it, is absolutely crucial to somebody taking ownership and acting like the steward we're looking for. Right? That's no negotiation about that, I think. So the final principle, if I had to choose the single most important principle, it would be preparedness. As a slight aside, this is an illustration of the Battle of Zama, which happened about 2,200 years ago, I think. It's where a Roman general, now called Scipio Africanus, managed to turn Hannibal of Carthage's elephants back on their own army, ultimately leading to their defeat. Scipio is particularly interesting in that he never lost a battle in his entire military career. And the outsized importance he seemed to place on preparedness and the act of becoming prepared. It was quite interesting. Now, since we're not at all concerned with military history here, to scope this a little bit more, I would define preparedness as both a practiced state of readiness and a recognition of the limits that you have in knowledge and resources and time and etc. To get into the notion of a practiced state of readiness, we're essentially talking about reflex. And I'll get to this story, which Chris hinted at yesterday as well. But I would say that not just from experience, because experience is a great way to build reflex, obviously. If you get hit a number of times, you start to learn how to not be hit anymore, right? But we also, from planning, research, and training, gain the reflexes that we need to deal with the things that we understand. Arts and athletics worlds have known this for literally millennia. And most of the great operations people I've met also understand this. One of the great recent examples is PagerDuty had a blog post about Failure Fridays not long ago, where every Friday they take a production system and start kicking it until it cries, and then learn how to fix it in production. At Acuity, because we're a little bit younger and smaller, we're doing full fire drills, where we essentially say, well, let's pretend production is gone. You know, Godzilla stomped US East 1, figure it out, and reconstitute our entire production infrastructure from scratch. We're aiming for like 2 hours or so right now, and it can be tricky. Now, to get a little deeper into reflex, Chris Maxwell, a friend of mine, hinted at this story yesterday, and I'm going to try and tell it for him. Sorry, Chris. But at one point in a past life, Chris was working on cruise ships, and on cruise ships, you have regular fire drills. And when you hear that fire alarm, first things you do are put on your uniform, so everybody else knows who you are, grab your life jacket, and something warm to wear just in case you're stuck on a life raft for a week or so. So sometime later, when he was working on dry land again in the desert outside Los Angeles, the fire alarm went off at, 3 or 4 in the morning in his apartment building. Somebody hit a standpipe or something like that. Very first thing he reached for, non-existent life jacket. But it's that repetition, that training, that reflex. That's what we want in everything, even whether your reflex is in response to something good or bad. You don't want to have to think about it. It just happens. Now, less often, we consider what our known unknowns are, and this is still part of preparedness. This guy right here, Augustus de Morgan, was a British mathematician back in the 1800s and said, whatever can happen will happen if we make trials enough. He was talking about a particular set of experiments, if I recall correctly. And basically, it's the earliest form of Murphy's Law that I could find. If something has any even remotely reasonable probability of happening, it's going to happen. It's like the argument about net splits. Net splits and partitions don't happen, except they do every day on IRC, right? Like, this is a known thing. So part of our job is to understand at least what are the events that we have not prepared for. What can we do to identify those events? And start to at least put things in place, put steps and knowledge in place to begin to prepare for it. Even if we don't have the time and resources now, that's fine. But at least acknowledge what may happen and try to have some clue as to what to do next. And basically, how do we begin to plan for the inevitability of these things? Now, that wraps up the principles. And so we're getting now into techniques and tools that support those principles. And I'm wary of placing too much emphasis on tools, because it seems to me that we as a community, especially developers, but generally the broader DevOps community, we have an unfortunate tendency to think that if we adopt tool X, we get the underlying mindset and techniques for free without any work, which is obviously completely false. It's important for us to recognize that tooling is really only 10% or so of the overall picture. In my mind, tools are a form of linkage between the principles and the techniques. By way of the tools, techniques support the principles, and the principles support that notion of professionalism I mentioned. So what are the essential categories of tools and techniques, I should say? These categories, telemetry, continuous integration and its cousins, continuous delivery, continuous deployment, excuse me, as well as automation, I think are the core set of techniques and tools that I would say support and reinforce the earlier principles. And I'll get into which ones support which. Each one of these categories supports more than one of those foundational principles, which, again, at the top, communication, ownership, and preparedness. So the first one, telemetry. Before you ask, telemetry to me includes metrics. It's everything from simple measurements of how long this API call took to, and whether it succeeded or not, to whether a service is present, unhealthy, or simply lost in space. It's important, of course, to not get lost in trying to measure absolutely everything right away. But I think that something simple like Graphite and StatsD is well within the reach of every single developer out there. Bear in mind, we're not talking about massive installations handling millions of events a second. We're talking about these small organizations who can't afford or don't know how to find operations people and just how to survive. The important thing to keep in mind here is that when your application is not communicating to you and telling you about itself, it's like going to the doctor and instead of describing your symptoms, keeping your mouth shut. It doesn't make any sense. If you truly lack the resources to do something like this, to put even Graphite and StatsD in, like if you can't get a tiny instance somewhere in Amazon, even something as simple as logging your how long an API call took in milliseconds, like putting it in your logs and getting a 99th percentile with grep and word count, that's at least a reasonable beginning that tells you something about what's going on in your application. And all of these tools have various ways via configuration management, scripted, publicly available ways to put them in place. Sean, I think where's Sean? Yeah, you have, for Sensu, I think you have Chef and a bunch of other stuff. Puppet. Yeah, that's just kind of ready to go, right? Point it at a box, go, done. Derp. So, the next category may be slightly more contentious. Continuous, pick one. The flavor you choose between integration, delivery, and deployment is entirely up to your business requirements and the resource limitations that you have. I will say, however, that that continuous integration is the bare minimum. I have yet to hear a convincing argument otherwise, but I'll address a couple of hypothetical ones just in case. It's not entirely unreasonable to say that continuous integration makes various branching models in source control difficult or harder. That's not a stretch at all. But I would say it does not preclude them. So if we go to the root of what continuous integration is, all continuous integration says is that all of these changes in various branching models, whether Git feature branches or what have you, those changes simply have to be reintegrated into the main or trunk branch at a higher frequency and lower granularity on a very, very regular repeating basis. That's the only thing it really says. And this is important because discovering that developer X forgot to put a feature flag on feature Y is just as legitimate a find and just as important to figure out as that same developer X with feature Y clobbered some required behavior or logic that some other aspect of your application depends on. Or heaven forbid, a health endpoint that your ops team depends on, right? Now there is a second possible, and I really truly hope purely hypothetical argument against continuous integration and its children, delivery and deployment. And that is that continuous integration imposes too high a testing burden. This position is nonsensical. If you do not write tests, you are explicitly choosing to use your customers as your test suite. And let me be clear. Your customers are your default test suite, and they are the most expensive option available to you. Before you've written a single line of code, you've picked that default. Two ways to disable the default, and only two. One, you write a bunch of tests that cover your correctness, quality, and availability to some sufficient level. The only other way to disable this is to simply go out of business. Full stop. Okay? It's you write tests or your customers are the tests. That's it. Now, the final category for operations people in the room is probably preaching to the choir, and for developers like Kelly. But in my experience, most developers actually aren't that familiar or comfortable with various categories of automation and the tools. It's not a silver bullet. It does take some work to use properly, but when you properly leverage it, it's a great enabler of both visibility, a form of communication, knowledge transfer as well, and preparedness. And I've subdivided automation into two categories, actually. And the first one is configuration management. There are only three things you have to do with respect to configuration management tools. Pick one, put everything in source control, and use it everywhere you can. Installing a database, configuration management tool. Spinning up a new host and provisioning it, configuration management tool. Deploying your code, configuration management tool. Use it everywhere, hammers and nails notwithstanding, but use it for everything. Holy wars about which one of these is the best or which one I forgot, etc., are not useful. All of these tools are good. Some of them are better at some things than others and vice versa. And to be perfectly frank, on a long enough timeline, you're going to use more than one of these anyway. So who cares? Pick one. At Acuity, we're using Ansible. Project-specific deployment and configuration tasks live with the project they're concerned with in the exact same repository so that anybody can just check it out and deploy it in whatever environment, whether it's on a Vagrant machine or EC2 or what have you. We have a separate operations repository as well, even though we don't have an ops team. And that contains everything from bare image provisioning, like putting host metrics collection in, to our Postgres configuration, React configuration, etc. Again, to reiterate, the important three things here to do are pick one, source control all of the things, and use it everywhere you possibly can. Virtually every time I've screwed something up with a new server or deployment, it's because I haven't used the tools that I already spent all of the time preparing with. Final category is platform as a service and infrastructure as a service. From an operations perspective, you may not agree that these are forms of automation. But because they drastically simplify the business of getting a production environment, I decided to include them anyway. I'm right, remember? To paraphrase the CTO of Guilt in a recent presentation, developers are not in the business of infrastructure. Anything that simplifies and streamlines the process of us putting product in front of customers at a higher quality level is pretty much by definition a good thing. And to be honest, we've never had it this good. From full cloud solutions like AWS and Google Cloud and more I'm forgetting to Heroku, App Engine, etc., it's never been simpler to get to production. Even SoftLayer now has APIs for provisioning bare metal. I think the turnaround time is a couple hours, but you can hit an API endpoint and you've got bare metal within a couple hours. Having said that, I'd still say that if you do not have an operations team, you don't belong on real hardware. The only exception I can think of is if you have very particular performance requirements. Then all bets are off. Get your butt on real hardware as fast as you can. To go a little further, in Acuity's particular case, so much of the heavy lifting has been done by Amazon and Netflix that it's frankly hard to imagine doing without half of these tools. Netflix tools ICE and SecurityMonkey immediately come to mind. So ICE basically sits there and watches a bucket with all of our accounting data from Amazon. Amazon just dumps it in this S3 bucket. ICE picks it up, tells us what we're spending per hour, per day on every single subcategory of AWS. Our not ops, but general corporate ops people love it. It's amazing. And it gives us a good metric as to how we're doing in terms of efficiency, what we're using too much of, etc. SecurityMonkey is great too. Everybody's heard the story about, I can't remember the startup, but they basically lost their business because somebody jumped one of their accounts and escalated through their entire AWS account. It was terrifying. SecurityMonkey, when somebody uses an IAM role's password or changes a security group rule or adds a machine to a security group, we get an email in seconds to let us know what's actually happening. And there's a full dashboard where you can say, well, yeah, any access with this, just ignore it, it's fine, and here's the reason for auditing later. To go a little bit further with this whole notion of, specifically on costing, with the pricing granularity available from a provider like AWS, for Acuity it's very valuable because we can pin almost every single, every single customer interaction can be pinned to an exact cost, or pretty exact. So when a new customer comes in and says, well, I've got all these many stores and these many events per day or per week, we can predict with really fairly high accuracy exactly what it's going to cost us to ingest the data, store the results of that data, query it a variety of ways, run a variety of reports for them, and serve it at every single level of our application. It should be immediately obvious how impactful this can be for the business. But to be maybe a little bit clearer, when somebody asks, like, okay, well, why are you guys so expensive? What's going on? You can just say, well, you sold it like this. There's all your data. This is exactly what it's costing you in every single thing. The immediate value of your efforts goes through the roof. To try and wrap this all up, because I know we're running short on time a little bit, this is how I see the techniques influencing the principles and funnel down to professionalism. It's worth noting, as I mentioned before, I think preparedness is probably one of the most important things, and all of these categories of techniques directly impact preparedness. Before I take questions, I think I have a couple minutes, right, for people to poke holes or ask questions. I just want to say a quick word of thanks to these people. Simon, Chris, Tyler, and Omar all provided a lot of valuable feedback and second guessing while I was putting this together. And at this point, I'm okay for questions if you got any, or if you want to just argue with me. Tyler, are we hiring? I don't know. No, okay. Nope. Sorry. Yeah. Yes, Vince. Yeah. Yes, there's some overhead in setting it up to pull from the proper places, absolutely. Right. Yeah, bad scene. Well, also, I don't know why you would be deploying code per se to your servers as opposed to artifacts, but yeah. Yeah. Anybody else? Yes. Yes. Yeah, I struggled with this a little bit because when you start to talk about culture, there's a lot of very deep rabbit holes you can go down. I don't think it's any news to anybody that we have large diversity problems in our industry. We have large respect problems, right? I was chatting with Jeff Hackert. I don't know if he's here today. Hey, Jeff. Jeff and I were chatting last night about this notion of empathy and kindness and civility. I think that this may be, again, a slightly contentious statement, but I think that the notion of professionalism, professional decorum, actually encapsulates these notions of having some sort of empathy for the people you work with and understanding that you have to communicate in different ways and that we all operate in different ways. I think essentially professionalism, and feel free to disagree with me, we can have a big argument about it. I think professionalism subsumes all of this stuff. That's maybe a bit of an old school position, and I don't mean to pass the buck on it. I just think that the conversation we need to have maybe needs to move more towards one of professionalism and what is a professional behavior and what does a professional culture look like, rather than, I don't know, the Silicon Valley dude bro, right? Omar.
You shouldn't be maintaining an awful lot of services. I'm wondering that are not core to your business. I'm wondering before those things are installed and deployed and run, if you consider outsourcing that to somebody else that does that as their main business for price reasons and for simplicity of your life.
Yeah, so you mean rather than using infrastructure from AWS or...
I was mentioning, like, I saw Sensu and
Yep.
all those things.
Yep.
You could simply, and you mentioned Graphite.
Yep.
You can pump those things into a service that does that even runs next to you in the cloud.
Yes. Yes.
Those tend not to be super expensive.
Yep.
I'm just curious, is it not worth freeing yourself up with that one instance?
That's a good question. And why we didn't do that, if I were to be perfectly honest, I didn't know any better.
That's a very good answer.
Yeah. Absolutely. There's lots of great as a service kinds of things for all of the monitoring, Graphite. I think, Sean, you've even got some stuff happening with Sensu along those lines where you just, you pay for it and it just kind of works. And if you have that option available to you and you're aware, like, try to make yourself aware of it, just use it, right? This is like in the early stages, if you're building a prototype, if you're a 2 or 3 person software shop with no operations, be deploying to some platform as a service. You should not be worrying about you shouldn't be spending a week on deployment pipelines. You should be building your product and putting it in front of customers, right? Yeah. In front of VCs works too, yes. Am I done? All right.
Thanks very much, Jeremy. I think a lot of us ops people would probably agree that that actually looks a lot like what it looks like when you do have ops as well. In the early days of an organization where there aren't enough hands to really go around building all the services that one might want. Sorry? So now we're going to take a short break for about 10 minutes. We're going to start here right on time. One of our speakers has to make a plane, so we really want to not run over this time. So welcome back, and please take your seats. Oh, my notes. Because on this amount of sleep I discovered this morning, I was not able to actually ad-lib. Steal. So we have a small amount of change today in our schedule. In that we're going to be doing, there are two our third and fourth talks in the opposite order. So now I can present to you Jennifer Davis, who's a chef automation consulting engineer who helps companies discover their own best practices.
Hello, everyone. Hi there. All 20 of you.
So today I am going to talk to you about magic, myth, and the DevOps. I am Jennifer, and you can tweet me at SIGJE, and I really like that because when I'm talking, I don't get to have that communication, and later I get to peruse all the tweets and actually respond to things that you guys say. So today I'm going to talk a little bit about what myths are and show you some myths that are present in our industry, and then talk about how you can speak up and sort of control your story and have a voice. So 6 months ago, I was at DevOpsDays Pittsburgh, and I gave my first talk at a DevOps Days. And I talked about the myth of heroism, because a lot of times we do things in a way that we consider heroic, like we save the day, we get on the machines late night like Batman, saving the day, changing them without any documentation. And one of the things I realized over years working at Yahoo and building really complex distributed systems
Is that was a false myth, and that what I had done is built a very complex system that, yes, was reliable, except for the fact that I was a single point of failure. But that was my talk 6 months ago. And I wanted to try out a new talk to talk about some of the other myths that are endemic in our industry. And so I am going to use some of our mythology that exists, and I want to make sure that I do not encourage heroism, because I don't believe we are heroes, right? We should strive to be zeros. And what I mean by that is zero impact to our coworkers, zero expectations, i.e., for example, if you're working late nights and on the weekends, unless you've taken time off during the week, that's setting an expectation that to be a good performer, you have to work all the time or not take vacation, right? So we are talking about the zeros journey, and that is that there is no one person that is going to save the day. And if you're expecting that one person, you might be doing it wrong. So DevOps is a myth, right? We come in and we talk about, at all of these DevOps days over the last 5 years, about what DevOps is. But the reality is it's a myth. Now, I don't mean it's a lie, because that's not what myths are. Myths are stories that guide our behaviors. We talk about them, we tell each other stories. They're based in tradition, and they change based on the backgrounds and the people who exist in that culture, in that time, in that space, and that now, right? They explain our world and our significance. What are we doing? Why are we doing it? Could we do it better, right? That is our myth. It's our oral history that's passed around to give a value to something unknown. So as we come together at these DevOps days and we share our stories, it's not about finding that right answer. It's about having your voice and finding that truth. What is the right way for us to work together? What way is effective? What can we take back to our cultures and our organizations? It's not something you can buy. It's not something you can sell. It's one part promise and one part warning. If you do this, this could happen. They're stories, and they have a power to cause action or inaction, which is an action in itself. They're magic. You can say something and have someone do something because of it, right? You're influencing someone. But that's what technology looks like to people, and it's not really magic. It's actually, they're programs. They allow us to alter our central algorithm. Why do we do the things that we do, right? How are we working the way that we work? One of the key things I discovered in how to break my algorithm, if I only document things more, if I only work harder, if I only explain one more time, if I can just train people to do this thing. And I realized he said, insanity is doing the same thing over and over again and expecting a different result. If my result is, I am the single point of failure, I need to change my activity. So how do I go about reprogramming that particular myth? So I'm going to tell you a story of a typical DevOps team, right? So there was this organization, and a senior team member realized that there was this urgent project that had to happen. Now, she wrote up this set of instructions, what needed to be done, and she contacted a senior manager in another group. And now that senior manager, he realized, based on his past experience, that you cannot tell someone how to do something. You have to get your group together, provide them the particular output that's desired, and the sort of rules about how you actually do the thing that you need done. So there was this young and experienced engineer who didn't have a lot of skills, right? He was in agriculture, and he had a little bit of robot knowledge, right? But unfortunate tragedy, right? We all have those things that happen to us that impact how we work and why we do the things that we do. And so he went to his mentor and he said, hey, these things happened. And his mentor said, hey, I have a job for you. Now he didn't say, we're going to save the universe. He had a small set of projects based from our senior engineer at the company of what needed to happen. Now, our senior manager here, he knows he needs more people, more resources, but he doesn't have a lot of money, right? So he goes and talks to some engineers, interviewing them, and he gets this contractor. Now, very senior contractor, has experience with a specific set of tools, but it's okay, right? Because he can get the job done, right? And he's motivated by money. So he's going to get the thing done, but he might be a little bit of an asshole about it. And he's got this coworker he's worked with for a long time. They get along really well. And this guy is super experienced, but has a few communication issues. So they come together, and this is our team. And this is what our everyday looks like. You know, you've got the team that you came in with, right? And they failed their first objective, right? Because you know what? It was an unachievable project, right? You're not going to be able to save that particular planet, right? Just not happening. But they didn't give up, right? They kept going forward and learning from their mistakes, right? And so why am I using Star Wars in this way? Because I want to expose some of the hidden myths that are endemic in our industry and tell a story that helps kind of seed these conversations that we can have later on throughout the day. And you guys can tweet at me, and we can start talking about explicit ideas around what we do and how we do it. So one of the first myths I want to talk about is that job wreck, or finding the one, and this misuse of ninja and rock star in an outside of the movies sort of place. There is no the one, right? It's not happening. This neo-fallacy, we just need to get rid of it. Imagine, if you will, if we had to create a job wreck to describe how we're gonna get this person who's gonna save the universe, right? It might be a little funny, we'll try and use some jokey words, But the reality is, right, we can see through this. And if we actually tried to find someone who matches skills, like, do you think that Luke would be like, wait, what? Carry 80 pounds of Yoda for a mile? What? Like, nobody has these skills. Nobody is going to be able to see themselves in the story, right? So our job recs are essentially stories we tell to enable and engage potential recruits to come do the thing we want done, right? A second myth is that interviews are gauges of skill, right? They do not tell you anything except how good a story you tell to the recruit and how good a story they're telling you and whether you all agree, right? So to pretend it's about skills, it's not. A third myth, education. How many people are on call right now? Yeah, so that's a sign to me. Right now you're getting educated. Right now you're working. And bummer, it's a Saturday. One, your company should make time for you to be able to commune with your fellow folks here where you're going across boundaries and learning from each other. And two, make that time there you're not on call. So a lot of time we treat education in such a way that, oh, I've got to get and do the firefighting over there. Like, I got to stop the training right now and go save the day. When the reality is, the training is probably more important than the firefighting. What would Luke have accomplished if he'd actually stuck through his training? The other aspect is, on the teams that we're on, we don't actually think of training as something that's fundamental to our job. When we look at how we bring new engineers on, we're like, here's a checklist. Go through that checklist when this thing happens. Now, how does that actually educate anybody, right? We need to treat training as part of our jobs to continue growing, and that it's critical for organizations to grow themselves, and that to bring new people on. Now, this is an interesting one, because I hear a lot of times about technology and individuals that are stuck in the past. It is entirely possible that you have people that are in cultures that have caused them to be reacting in fear and not responding and growing. But this is those engineers, they're really capable, but they have outdated tools, and all they need is a translator to help them understand what is available. So the Ewoks weren't just like, hey, we're gonna eat you. They were like, oh, okay, yeah, we'll save the day here and accomplish this mission. So let's stop discounting our engineers that have awesome skills for a reason. They just aren't using today's technology. This is a controversial one, and I want to explain it a little bit. There's this idea that we can be productive alone. Sure, you can totally be productive alone, but then what does that productiveness look like? We are all in systems, and what we do impacts and affects other people. In order to improve and shape ourselves, we have to work with other people. A lot of times I hear people talking, we separate ourselves into the individual contributor and the manager. The reality, we should all be leading, right? If I get trapped into this thought that, hey, I'm an individual contributor and I can be awesome at this, I get stuck in a learning cycle. I don't want to compare myself or learn from other people. There's this myth that there's a right way, right? If I look at all these different themes of different teams and how they react, are we actually wanting to be more like the Federation and the crew of the Enterprise, reacting to the Federation's rules and regulations? Are we wanting to be that small, effective team that goes out and saves the universe? Only you know where you are right now. Only you can identify the culture you are in and how you're going to impact that organization, including your choice to leave, right? You don't have to stay in a horrible organization. So changing your organization involves looking at your current team, the background of your team, and all the individuals in their culture. We can identify bad cultures, right? the stormtroopers who are told, you are a stormtrooper, you do exactly what I say when I say it and now. And there's no diversity within the actual team. So they can succeed for a short time, but it's not sustainable, right? And there's also the Borg. And you can see and identify these by the factor of it's always about growth and assimilation. Let me assimilate culture into our culture. There's no individual expertise, right? There's no encouragement of family or outside activities. There's nothing to celebrate when the reality is we're all just doing the same thing and struggling and fighting against each other. And this is all about fear culture, and I see this endemic all over the place. And we don't even realize it sometimes in the ways that we talk about ourselves and we talk to others about what we're doing. So what does that look like? One of the things is if you have team members and your organization is threatening, if you make a mistake, I'm smart. I'm not going to look at something and go, hey, I'll totally volunteer to do that really risky thing because you're totally going to fire me if I fail, right? These are the red shirts, right? For Star Trek folks, I'm not blending my... I'm using from many things. And then an even more threatening thing that I see that's actually really negative is this concept of role adherence. And what I mean by that is that I am a thing. I am a developer. I am an ops, and this is what I do. Imagine for a moment if a farm boy thought, I am a farm boy, or a smuggler said, I am a smuggler, or a princess said, I'm a princess. I'm not going to do any of these things that I feel called to action to do. When we constrain ourselves, we constrain others. And I see it endemic in how people say and talk about things. When you hear a developer does, or a developer likes, or an ops does, an operator likes, or ops, it's just a detriment to the team and a detriment to our whole organization and industry. We are all individuals, and we are coming to the table with a specific set of skills, and we can learn. And we can do anything that we want to do. Roles are just guidelines, right? So, how can we do it? How can you do things? Let's start speaking up. It's not just about me or any of the other speakers today, and it's all the groups that meet together. Each one of you has a voice. And why? Because you can change your organization, and you can educate the people around you and the people you don't even know that you're going to meet. And you can influence the community, because DevOps is a myth. So what strategy should you take? You should be explicit. Make sure that what you're doing with your story is an informed decision-making, and encapsulate your aim and the key values of what you're trying to accomplish. So some people might say to me, totally speak up all the time. What are you talking about? I tell my boss all the time there's these problems. The truth is a collection of all the voices. So just because you're speaking doesn't mean that you're right, and it doesn't mean that your boss can hear you. And so you have to listen and understand who is involved and affected by the story that you're trying to tell. Are you actually reaching them? What is the current state of the people that you're talking to and speaking to? And what are their culture and beliefs? This is a really scary talk for me because I'm in Canada and I don't know, am I connecting on a cultural level with you? And that's difficult because I am not Canadian, right? And so you always have to be aware of the not. I am not. Because understanding whether you have diversity in your team or not is really critical. You don't want to be the stormtroopers wandering around being somewhat successful, but not sustainable because you have all these unknown weaknesses that someone's going to eventually figure out, right? If you look at DevOps, and one good example of this is examining the DevOpsDays Against Humanity cards. And you look at the words around DevOps and what culture the story we're telling, the myth of DevOps, you can see things like eat sushi with Clay Schaefer. And what is that telling us about our culture? That we encourage friendship, community, and talking, and eating tasty food, right? Sparkly DevOps Princess, because we care about diversity of women in our industry, right? We should all examine what words and stories are we sharing and talking about within our communities, within our organizations, within our teams. Identify the inconsistencies, right? Internally, we can make up something and it might not be consistent. When we see the set of voices and when there's something that's wrong, we need to identify that. So if someone's trying to sell you DevOps, that's an inconsistency with the overall theme of what DevOps is, what myth, the culture that we're describing. So I'm not going to go into all the science, but you can read a lot about organizational learning from these folks, but I am going to steal some of their themes to share with you. And there's this theory of action, that internal set of rules where we say, here's how we act and why we act, because we think we're all reasonable, rational human beings. And then there's the theory and use, things that we actually do, and then we'll try and accept any data and stories that match with our story. So when we're trying to make a change, we have to realize that everybody has this interior dialogue going on of like, yeah, here's my checkpoints to compare against. A lot of times, if you look at organizations and teams, you'll see this sort of Model 1 way of communicating. And it's kind of like the thermostat. If the thermostat reports 68, the furnace comes on, right? If our team has an outage, how do we respond? Do we actually have a blameless postmortem and change how we're doing what we're doing? It's not wrong, right? It's critical to how we accomplish things. It's something we learn really early, but when it's negative, it can turn into very blame type cultures. And this is where, as Jeff, my coworker, mentioned yesterday, we get that skilled incompetence. It's not that we're not skilled, right? It's that we are capable of learning anything else because we've got this internal story that we're sticking to, all the rules and regulations, and we only take data that matches what we're thinking. I see a lot of this in organizations that kind of have this sort of negative Borg mentality where everything is about bypassing any sort of data that might contradict and then covering it up, and then you have to cover up the cover up. It's sort of like that negative feedback loop. And you can see it when individuals are talking about how this organization is failing, but they don't feel a responsibility to make a change. I will tell you, as a person that believes strongly, if I've joined an organization, I'm going to speak out and make changes. I'm no longer going to sit back and say, hey, I keep doing all these things and nothing changes, right? If you are at an organization that is in this place, you always have the choice. You can make a change by leaving. So focusing on all the negative aspects and downplaying all the positive, that's another indication. And then if you're actually like embracing some kind of magical tool that will solve everything, and if only we did that, that would make everything change. Again, it's time to change your interior dialogue. So one of the things I've seen, I'm going to give a little story because not all of us are really good at telling stories. We don't all have to just be speaking out stories. We can use our metrics to tell a story as well. It's very effective with management because they don't like lots of words. If we can get to that second level, this model 2 of communication, we get this double loop. And it means that we're focusing on slowing down, making reasons or excuses, and actually stepping back and analyzing and having that increased reflection. So one of my old coworkers shared this story with me after joining a new team and embracing these whole values of being a zero. And he has this great communication with his developers. And so what this is showing you here is you see these light red and dark red? That's the application. In light red, the application has a single host going down, and it's like a web front end, so one host, like danger zone. When it's dark red, the site is down. So you'll notice this went on for a little bit, right? And they kind of saw hints of problems. And so in some organizations, that would be like, you need to work this crazy hours all the time, blah, 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 blah. Well, so that's not how their organization worked. And so what they did is they had Chef installed, and so they could actually quickly iterate over different sets of changes. And so there's this awesome thing about Postgres, and if it has this fill factor, and by default, it's set to 100%, but I'm getting ahead of myself. So in the beginning, they tried changing out how they actually did their SQL queries. So developers and operations are working together to figure out what the problem is. So they change from a sum to a join. And so the overall context of the experience improved, but there was still this underlying problem. So then they continue to make changes. You can see time goes on, time goes on, time goes on. And I'm totally messing up the video stream right now. And you see this drop here? It's going from tuning the applications, tuning the hardware, to tuning Postgres. And so what they did is take a look at the fill factor and change it from 100%, which causes you to have fast writes but slow reads, to giving it some space. And so then you got the faster reads, and the writes were a little bit slower, but that was okay. So story that management can look at, people working together, there's no blame. None of the devs are looking at the ops folks going, you guys need to fix this, right? This is a sign of a very healthy organization. So there's technology you can use to tell stories, like I said, and there's this concept of graphs with overlays. I also encourage people to use Kanban boards, you can see the work, your management can see the work. Everyone, I brought this into a team at my previous employer, and everyone stopped being so fearful of each other because they were able to see everybody's actually doing, so it's all good. Track your time. So it actually tells me a story from like 3 weeks ago, and this tells me, right, I'm using, this was 63 hours. I worked way too much on a computer because my job is actually more than just computers. I actually have to talk to people as well. So this reflects to me, hey, you know that story you're telling yourself of getting enough time with your family and friends? You're totally not doing it there, right? And so I'm able to have that external check to keep my story consistent. So, boss, I'm taking more time off. So today, I've talked about myths. I've talked about seeing the myths and speaking up because everyone should have a voice. I want to say thank you very much because this has been an incredible experience, one of the most friendly audiences I've had at any DevOps Days. Please do get in touch with me on Twitter, email. I'm sad I'm not going to be able to talk to you all during the open spaces, so please do talk. And with that, I just want to leave you with this saying from Yoda.
Thanks very much, Jennifer. That was really fantastic. Next up, we've got Alex Cruz from here in Vancouver. He's works at Metaphor as director of architecture, and he's been architecting scary, bleeding-edge, speculative software for 15 years, which sounds like a terrifying existence to me. Please bear with us at just a moment while we get an actual non-Mac set up here for a moment.
That might be a little close. Can you just turn it on? Sorry, there's some weirdness with it. Super. Let's review. It should be now. Test. Good?
Great. Yeah, there's no
Cool.
volume control, so just bring that farther away.
Sure.
think that's the speculative software. Okay, by the way, so next up we're going to have our Ignite talk. So if you the Ignite speakers could move on down here to the front, we've got some space for you, just so we can get you set up and ready for what's going to happen.
I'm having a few problems right now. So I'm just going to try read.
Oh, there we go. That looks better. Yeah.
All right. Yeah. So I'm having trouble here. Okay.
So we use Google Docs. So actually, can you upload it to Google Docs? That might, or you can't get anything at all.
Yeah, I mean, I can.
Bear with us during these small technical difficulties.
Linux.
Is that a full reboot I just saw?
What?
Is that a full reboot I just saw?
Yep.
Oh my goodness. People are leaving. That's bad. So we're just going to have to compile a new kernel and roll out a patch. It shouldn't be more than a couple of hours. I'm just giving it a hard time, Alex.
Life on the bleeding edge.
Yeah, it's a thing.
I can send you a previous version. It's not that old,
Why don't you
actually.
send me that first?
Yeah.
Just a demo at gmail.com. So demo spelled like that. Share me that. We're gonna be like that. Meanwhile, log in and see if you can send that up to Google Docs.
I don't know if I have internet still.
That would be fantastic. So if you plug this in now, it just trashes it.
It seems like it, yeah.
All right. Plug this into the wire. So I've got your old one.
Yep.
Send me a new one now? You don't have a new one.
Don't worry about it, it's fine.
this is going to do what I want. So I'm really hoping this is going to do what I want. That looks positive. How can I present this? Can I convert this to... Oh, it's only letting me view it. So... So this is the best that I've got, actually. It's better than nothing, but it's basically left and right. Oh, shit. Are you serious? You'll have to scroll down and make it page down. I'll have to stay up here and deal with this for you.
Wow.
Well, I mean, I don't have LibreOffice installed on this machine,
Yeah.
so and it won't convert it. So I can't do that as far as I can tell. Yeah, unless I can import or something here. I don't think there is. Oh, fuck off. Import slides. Oh, maybe I can do that. Hold on. Let's try to create presentation. Create a share because it just happens to be in the thing. I'm going to try and import slides. Cancel that. Get out of here. Import slides. Let's see if it'll let me do this. Watch this be just another Google Docs thing. Just upload. Select. Downloads. Way at the bottom for some reason.
God damn it. Let me just try another attempt
One
here.
more time. Do you have
It ignites in like 3 minutes if you don't do this.
I can show it. It just looks like crap. So is it going to display? That looks impossible. No, it's not going to. All right.
Wow.
Wired and thing. And so we're going to have to be a little bit creative here. It's an OpenOffice presentation, and I actually have not yet installed OpenOffice or LibreOffice on this machine. You have OpenOffice? ODP? No, I also have a regular Office. And so what we're going to have to do is I'm going to sit here and change slides for him. It's not a...
Yeah, I can do that.
Yeah, that would work. That would work if you can export it. Export to PDF and we'll be much better off. Here's the email to him. USB key. USB?
Yep. Yeah.
Yeah, but we're just going to do a PDF export, I think. Then bring it. I have to talk real fast. So I think in one of the open spaces, we'll have a blame-free postmortem on this. In the meantime, you can just like breathe in and out. I got a sudo now. You in there?
No. Actually, I have an old version on here. That's fine. No, I mean, sorry, I do need your laptop. Okay.
I'm just kind of glad we're not reinstalling an operating system at this point. Yeah, right? Fire up Cobbler, you know. Trying Pixie Boot off the wireless network here. That could be fun.
I opened this morning and I guess somebody from Salesforce like pushed laptop updates and mine like closed and restarted. And my presentation was like 10 restore 1. And I'm like, oh, awesome, perfect. I'm on the train. Like, please don't be there.
But it's cool because you've got all your stuff is backed up, right?
Right.
Right.
Technology.
I just love that like thrill of like, all right.
Do you have a copy on there too?
I don't have a copy on here at all yet. I have the old version, I guess. Is it? Oh, do not tell me that's going to mess up too. It works. We've been using it all day. Maybe arrangement. I promise you, we've been using that all day. Unless I got unplugged on this end. No, it's good. Bing.
There you go.
Thanks. Let me get that. Hey, thanks for your patience, everybody. I present to you Alex Cruz.
All right. Really a little bit new at this, and I have technology issues, despite being a technologist. So if I speak too fast, that's a tendency with me. Just do the wave, like maybe from bottom to top if I'm too fast, or no, never mind. So who am I? I'm a self-taught programmer. I'm a university dropout. I've worked at technology-intensive companies for over 20 years now in Vancouver, mostly software companies. Some of them are still in business. 2 of them were acquired for pretty good money. Layer 7 is one of them, and the other one was a little one called Subservio. I've managed to snatch defeat from the jaws of victory twice now. I'm hoping not to repeat that. And my computer science is something that I came to because I felt like I needed it, not because it seemed like a good idea as a career when I was a kid, basically. Which I think is, both a blessing and a curse. So in terms of declaring my biases, I really like static typing. I really like functional programming. I'll explain a little bit more about these if you're not familiar throughout the presentation. I've internalized a lot of the Java ecosystem over the years, and as you might expect from the preceding, I really like Scala. And in fact, I still like it 5 years in. I have a tendency to sort of go on EVAs, architecture astronaut EVAs. It's like when you put on your spacesuit and go outside the spacecraft, that's an extravehicular activity. But I'm working on it. I'm trying to cut back. So the outline of the talk, so some sort of general pontification. When you compare yourself to a pope, it's not always a good idea. But and I want to talk about some hard problems and some candidate solutions, some of which suck less. That we kind of need to figure out if we want to stay employed and stay relevant, because the world's moving in this direction and we want to sort of follow along. We don't just want to keep confined to a small area in the solution space. One thing I should say is that I'm not claiming that any of this can be made easy. I'm just saying that there are some patterns, frameworks, technologies, libraries that really do seem to have the properties that are desirable here. And please, if you have any approaches that you've used that I don't mention here, that you found have been really productive in solving these hard problems, then please let me know afterwards, or during the questions if we have time for them. So this is just a sort of ridiculous position statement from my proposal. So the idea basically is that traditionally software development lifecycle involves things like implementation, maintenance, enhancement. And now the success of software critically depends not only on that traditional software development lifecycle stuff, but also on deployment, operations, sort of the DevOps concerns. Basically, all software is moving in the direction of requiring operational control and maintenance and management. So here's a quote from a famous Russian developer of literary fiction. And the idea is, so everyone's heard this quote before, the idea is, put another way, there's a lot of things that have to go right in order to sort of achieve success. And if any one of the little things sort of goes wrong, then things can go off the rails in really spectacular fashion sometimes. Just think about the combination of cheap steel and icebergs, right? These are just small things, but sometimes they really turn out to be critical. And so you sort of extend this to software architecture. One thing that I like to say is that small systems, if you build a lot of small systems, they all kind of start to repeat, right? There's a loop in your workflow where I've assembled this toolbox of solution patterns, whether templates, whether mental or literal templates or both, and I can sort of apply them to every problem that I see. Works pretty well. And it's a leaky abstraction, but large systems though are not the same, right? Large systems are all unique, much like all unhappy families are unhappy in their own ways. And what I mean by that is that the solutions and the techniques and the technology sometimes that you have picked up over time building small stuff cannot always be applied in any kind of clean way to building large systems, or at least not nearly as cleanly as we would like. So here's a little minor digression into project risk factors. Really, what you want to try to do is to minimize, you don't want to buy all these risk factors all at once, right? You really want to try to confine yourself to as small a subset of them as you can. So you get problem domain risk factors, right? So sometimes the problem domain itself, no matter what software you use, no matter what your solution looks like, the problem domain is inherently full of hairy yaks, right? That sucks, but, well, I guess that's just my life, right? Some of them, they're not necessarily complex, but they're just unfamiliar. You need to learn the problem space before you can really address the solution. You can also run into tooling and infrastructure risk factors. Your technology is unfamiliar, your technology stack is unreliable. Sometimes things are new, sometimes they're buggy. Sometimes you just don't know it yet. And of course, scale is itself a huge risk factor, right? If you're building a small thing, there are fewer things that can go wrong with it, right? When you're building a large thing, there's a lot of parts that can fail, right? So ideally, you want to minimize as many of these as you can and try to only bite off small nibbles of risk factors. So the first hard problem that I want to talk about is scale out. How does scale out cause problems? Well, this is a little bit obvious to a lot of us, but basically the complexity of the overall system increases, right? There's more moving parts. And it becomes really, really difficult to the point of intractability to reason about the behavior of the system as a whole, right? The whole application, all of its components and services and dependencies, it's really hard to form a mental picture of how it actually works in detail, right? And of course, keep in mind the airplane rule, right? So all else being equal, on average, a twin-engine airplane has more engine failures than a single-engine airplane. And you kind of hope that this leads to, well, at least we can tell ourselves that at least we can survive an engine failure. But in practice, it doesn't actually work that way as much, because it turns out that when one engine fails, the pilot gets really distracted about trying to restart that engine. And I can still make it. And and flying gets a lot harder because now there's differential thrust, right? The airplane wants to turn now because one of the engines is not working. And it turns out that you're much more likely to have an accident of pilot error when you have half of your engine out than if your one engine is out. It's like, okay, well, time to land. The flying part of the trip is over. It's time to find a flat spot, right? So why do we need it? This is a bit kind of, I like apple pie, right? This is a bit obvious, but obviously a single server that you can run the entire thing on is really expensive if you can even buy one, right? And worse yet, it's impossible to have a single server that can run the whole thing forever, right? You just have to have redundancy to achieve fault tolerance and high availability. And redundancy, of course, invites coordination problems. And of course, ideally, one of the aspects of scalability is we want to start with a small system and then grow it incrementally over time without spending a huge amount of money up front. We want to spend small amounts of money as we progress without having to redesign everything. So there are some things that we've tried to solve the scale problem. One of them that we've tried, it seems like we've burned quite a few decades now, is trying to simplify our life as developers by making what is not local feel like it's local, right? So we're pretending that system over there, it's just a regular object, like a distributed object. We can make a method invocation, get a result back, and we're good, right? So, Corba is in this category, DCOM, same idea, EJB, distributed transactions, SOAP, RPC, all these technologies that we've burned decades, literally decades on. They're all about trying to hide the network, basically. The problem is that the network is always there, right? So see the 8 fallacies of distributed computing. Do you want me to list them? Anyway, easy to Google. There's leaky abstractions, right? There are so many things that can fail in between expressing the intent of making that request and actually getting a response back and deserializing it, and et cetera. And these things that can fail never make it into the API documentation, right? So it's really hard to build a system that relies on other systems in a reliable way if you're pretending that it is not going to fail, right? And of course, if you do RPC-style things that try to make it look like local, you often have blocking, right? Like you make the request, you sit there waiting for a quarter of a second sometimes for the server to come back and give you the response. Sometimes the server's even blocking on the client request too. So every time you're blocking, you're limiting scalability, right? There's a thread sitting there waiting, you can't do anything else. And threads are cheap, but not that cheap, right? Like it's a few thousand threads is no problem, but more than that, diminishing returns. So another thing we've tried here is we've tried using a huge number of dumb, cheap servers in the front end and a smaller number of sort of expensive, beefy servers in the back end to do the heavy lifting. And it turns out that what happens here is you run into the early Twitter problem, basically, where the back end becomes a bottleneck, and there's nothing you can do. There's no way to add capacity in any of your layers that will actually solve the problem. And we know for a fact that it's really, really hard to scale the back end, the stateful part of it. It's science, right? It's the CAP theorem, right? We know that's hard to scale. So you need to find some way of moving beyond this sort of dichotomy. One thing that we've tried, which is actually kind of okay, is actors, message passing, location transparency. This is going to become a theme. So it has problems. You need to rewire your brain, basically. Actors are a very different way of modeling solutions compared to standalone services, other abstractions. You need to rewire your brain. You need to rethink how you build systems and purely local interactions. So the things that RPC was lying about that are actually local turn out to be more cumbersome when you're using actors than if you're just making direct method invocations. But what is going right is that you have a narrow unifying abstraction that covers local interactions and point-to-point interactions and clustered interactions. And when I say a narrow abstraction, it's important because the less the abstraction promises, the less it can lie to you and break its promises. So you really want to try to keep your interactions with the outside as going through a pipe that's as narrow and as understandable as possible. And one cool thing is that the participants in message exchanges don't need to be aware of where they are, right? They could be a bunch of dudes in the same machine, they can be clustered, they can be across a continent. Sometimes you need to build in a little bit of rack awareness to make sure that your latency is optimized for your application. But basically the idea is that when you're making decisions about your application's topology, namely what's deployed where, is something that you can do as configuration at runtime, and you don't have to have, this guy knows that he's making an HTTP request over the wire to that guy, right? He doesn't care. All he knows about is a guy that I can send a message to and trust that I'll get a response back sometimes, as long as nothing's failed. So concurrency is another hard problem. Somebody on Stack Overflow, not me, used this analogy. Concurrency is like having a juggler juggle many balls. Regardless of how it seems, the juggler's only catching or throwing one ball at a time. And parallelism is like having multiple jugglers. So concurrency is not parallelism. Parallelism is simpler and easier in many ways, and can even be done for you by the library sometimes. But concurrency leads to non-determinism, basically. And it means that it's really hard to reason about code when it's non-deterministic, when you can't predict, just based on reading the code, what order things will happen in, right? Or whether things will succeed or fail. And concurrency bugs are some of the worst. They often show up only under load, and they're a pain in the ass to troubleshoot. So you should try to avoid them. But why do we need concurrency? So why do we need it? Why take all this, incur this cost? Well, we want to make best use of the system we've got, right? You've got 16 cores in your server. You really want to be able to do as many things at once as possible, concurrently. And even if you're not using threads or shared memory, your application still has state that it needs to trigger and communicate and notify and commit and roll back. Like your application fundamentally is doing manipulation of state, right, as a significant part of its operations. And it still has to happen, whether it's shared memory or not. If you can use shared memory, then you get a bunch of stuff that's cheaper, right? You don't need to do a codec every time. There's no wire to go talk over. So one thing we've tried to solve the concurrency problem is use threads, share a mutable state. The problem is that almost nobody is smart enough to do it correctly. I used to be able to use threads correctly, but I think I lost that part of my brain when I was in my 30s. So there's a rich vein of bugs to be mined there, and you don't see them until it's way too late. It used to be, in old man territory, it used to be that workstations were all single core and servers were multiple CPUs, multiple sockets. And there were certain classes of bugs that you could never see on your workstation because you only had one CPU. There was no true concurrency. It was all simulation. It was all task switching. And then when you had actual parallelism to work with, then you would actually see the bugs. Now, of course, we don't have that problem so much. What else have we tried? Just don't do it. Avoid concurrency. The problem is that we're not making best use of our resources, right? Some tasks are inherently concurrent. They really want to have multiple things operating at once, and then they need to coordinate. They need to sort of split and rejoin during the normal course of their operations, right? And if you're doing your coordination externally, then of course you need to wait for it. If you have a memcache server or a database, et cetera, right? It's just sitting there waiting for the damn thing to respond. Limit scalability. Sometimes you really want to have local state. So another thing we've tried here with concurrency is actors. This guy again. It's not perfect. One problem with actors is that some of us are addicted to types, and actors kind of throw them away. Messages are inherently untyped, basically, at least with the traditional Erlang and Akka. We're working on it. Things are improving, but it's not there yet. Also, message passing is not nearly as efficient as method invocations, right? So if you're sending 1,000 messages per second, it's no problem. You're never going to notice a difference. If you're sending millions of messages per second, you may not want to use actors. Message passing, it might not be a good fit for your application, right? But what went right? Actors are not concurrent. So individually, any single actor is not allowed to do multiple things at once, right? The framework, the system ensures that only one message is ever going through your receive method or your loop at a time, right? So actors are perfectly safe to use mutable state internally, as long as they don't talk about it very much. And of course, actors are also decoupled from threads, right? So you can have literally millions of actors that are alive on a system. They're all just waiting for messages and doing their thing. And you can have a very small number of threads, as many as you need for the system to progress, right? Enough threads that you progress, not so many that things are inefficient. Another thing that helps with concurrency is immutable data and functional programming. It requires some brain rewiring again. This is a bit of a theme. A lot of these things don't map well onto traditional practices. And sadly, sometimes there is no incremental way to get from the way you build things today to a much better way to build things without just replacing components. It's not always so bad, but to keep it in mind. Brain rewiring, again, some languages make it hard to use, but get a better one. And functional programming itself doesn't provide concurrency per se, but what it does imply is that if you have functions that are pure, that are referentially transparent, meaning that you could take the result, you could remove the function call and replace it with its return value, then the system can actually parallelize it for you, right? You don't need to say, well, this should be in parallel. The system can actually do it automatically. In theory, it's a bit bleeding edge, though. And what you actually get declarative programming, like truly declarative programming, not just a pipe dream. It really is declarative, at least in the small, right? Declarative in the large is still a pipe dream, but in the small, you kind of have it now. Fault tolerance is another hard problem. This slide is a bit weak, obviously. Error handling code is ugly and it gets everywhere, right? It just gets sprayed through your whole system. And ideally, you want to find a way to avoid having to write that code everywhere. My preference, at least, is error handling code everywhere. It would be nice to have some way of avoiding that. So error handling code, it hurts composability, which to me is the property that two pieces of code that were not necessarily designed to work together can be made to work together without a huge amount of pain, essentially. Of course, fault tolerance is just another slice of apple pie, right? You kind of want it. But what's wrong with exceptions? Exceptions, they work pretty well. The problem is that they're really hard to fit cleanly into static type systems, right? So imagine you have a function type, and it has one of its type parameters input value, and one of its type parameters output type. But then, let's say the function is making a database request and writing out the result to a file. Well, the IO exception and SQL exception are not part of the function's API, right? There's no good way to declare all the things that can go wrong at an API layer. And also, you have this non-local transfer of control, right? So when an exception is thrown, it could be thrown in code that's really far away syntactically or lexically from where you're actually catching it. Sometimes it's really hard to reason about what the system is going to do. Fault tolerance, multiple return values. This is a bit of a mumble, but it just seems weird to me. It's verbose, but people like Go a lot, and people seem to ship a lot of really cool software on Go, so I'm not really going to express this opinion too forcefully. Whatever they're doing, it's working really well, so I'm not going to complain. Another fun thing is we've also tried to use algebraic data types instead of exceptions. So we're taking things out of a language feature and moving them into a library, right? So one classic algebraic data type that you see in Haskell and Scala is maybe, right? There's a value or there's not a value. There's also one called either, which is it's one of these or one of those. So it's not nothing or something. It's one of these or one of those. There's two different disjoint types that it might be. And in Scala, there's one called try, which is sort of a way of wrapping exceptions. So they look like algebraic data types. Again, there's brain rewiring, right? You need to change the way that you're thinking about your code. There's lots of benefits to it. Don't get me wrong. And eventually, you'll see a win here. But the problem is, it's not a easy, quick fix. And if you have existing code bases, it's a little hard to retrofit. But for new code, it's fantastic. You can use all kinds of great functional programming combinators and libraries for error values and normal values, and it all looks the same. Like there's no special case for exceptional conditions, right? It's just part of the normal code flow. And you can also, if you have the ability to use algebraic data types and like option and either and so on, you can actually implement them locally and then just have adaptation layers around them that make things kind of compatible with your outside world. Oh God, it's actors again. So one thing that's interesting about actors from the fault tolerance standpoint is that the rules for how actors fail and for how the failures are dealt with are really, really simple. It's like one slide to explain how it all works. And in practice, Ericsson is getting 9 nines of reliability out of some of their phone switches. Now, of course, most likely there's some hardware secret sauce in there as well. Like it's not just the software that's giving you 9 nines. There's some kind of redundancy in the hardware that's doing a lot of the work. But it's an example of a pattern that really can deliver tremendous reliability using simple rules. I'll get into the rules later. So one of the last hard problem is correctness, basically. Like how do you have assurance that your code is correct? How do you know that what you intended to deliver is actually what it actually is? And this is hard. There's been a lot of techniques for improving correctness over the years. A lot of them are hard to learn, bad for performance. They rely on programmers to be better, which is not something that I'm willing to do. But again, we have no choice, right? Like we need to try to avoid bugs. Systems are more complex. The more complex your system is, the greater the chance that a bug in someone else's computer is going to affect your system, right? A computer, that's the standard line. A computer that you've never heard about causes your system to fail. So one thing we do is test-driven development. It works pretty well for some people. It can be a big culture shift. It requires programmers to be better programmers. Again, not doing it. And dynamic typing. If you need to test things that are like sanity violations, then fine, you do that. But of course, it actually works as long as you get enough buy-in. And static typing helps a lot because it compiles is a huge part of your test suite. Sanity violations just don't happen in practice, barring various kinds of cheating, like reflection and so on. We've also tried to do static and formal program verification. This comes with some terrifying tooling a lot of the time. And really, very, very few useful real-world problems are actually amenable to static and formal verification. When it works well, and luckily languages are moving on this turf. So what used to be something that you would exercise discipline is now something that the compiler is doing for you, if you have a sufficiently advanced compiler anyway. So a quick digression on abstraction. Avoid it as long as you can. Abstract code is harder to read because details, by the nature of abstraction, details are moved out of the sort of context where you're dealing with them in the abstract, and they're somewhere else, right? And understanding is really important. Like sometimes you really want to be able to read the entire thing in one page of code. and not have to jump around between implementations and abstractions and concrete things. Big design up front isn't always wrong, and you ain't gonna need it isn't always right. So sometimes you need to find a balance between those two. For your particular project, depending on risk factors and team composition, et cetera, you need to work out how much big design up front is appropriate for you. And really you should try to delay creating new abstractions until the repetition is starting to hurt, basically. Because a lot of the time, the abstraction it gets in the way, right? It creates noise that gets in the way of understanding the code. One thing you could do is use richer languages and libraries. So if you have abstractions that are already there, you don't need to write your own. So you know what an either is, you know what an option or maybe is. It is an abstraction, but it already exists. People can read it and understand it. They don't need to figure out what you mean by, oh, the extract result is either I got one, or the value was too old, or it was filtered out, right? If you can use someone else's abstraction off the shelf, then do it. And concision is important too. Smaller code is better code, and you should, if your code is smaller, then you're less tempted to use abstractions to hide irrelevant details, right? Because the details are relevant. You don't need to hide them. So we've gone over some problems, and here are some proactive meta solutions. Actors, obviously, they can help you in scaling, concurrency, and fault tolerance, as I've already talked about. I'll get into each of these in a little bit more detail. Functional programming helps with correctness, especially if you have static types, and concurrency. Immutable data helps with correctness and concurrency. And I guess since it's DevOps, I have to talk about configuration management, but not in any detail. So what is an actor? Actors are actually really simple conceptually. There's like 2 pages of description of what they are. They can create children. They can send messages to other actors. So importantly, that message send 5 minutes is not necessarily local. It could be remote. It's not necessarily to your own child. It could be somebody that is not related to you hierarchically or in your parentage. You don't necessarily want to expect a reply. Sometimes there's one-way messages, totally expected. And you can also include reference to other actors, including yourself. Whenever you send a message, you can say, talk to that guy. Totally valid. You receive messages, and you execute code based on what the type of the message is and what it contains, its type and its data, right? You can change your own behavior. So you get a message that says, oh, now you're one of those, no problem. You can become something else. You can have either a stack of behaviors that you can unwind, or you just have a bucket brigade of state that you just move forward through time, having a different kind of behavior. And you can also ask to be notified when someone else has stopped, right? So you can do some cleanup or whatever. Actors cannot, as I said, process more than one message at a time. So an important aspect of an actor library or framework or language is that it prevents you from receiving 2 messages at once and interleaving the processing. There's always a strict sequence of messages being processed. And actors should not attempt to directly observe the state of other actors, although sometimes you can cheat, but you shouldn't, basically. And you should not also send mutable messages. That way lies madness. So actors live in a tree. When an actor crashes, like an exception was thrown, then it gets restarted automatically, at least by default. But a parent actor can override the fault handling behavior that applies to its children to do things like, okay, if any child dies, restart them all, that kind of thing. So, functional programming. Avoiding side effects is good. Of course, programs exist for their side effects, right? The whole point of running the program is to have some impact on the world, interact with the real world. But if you can sort of keep the pure stuff inside and then keep the side effects on the outside, it makes it much easier to reason about code. You can reduce code size with declarative programming and high-order functions. And as I mentioned before, functions that are referentially transparent can actually be run in parallel automatically, although sometimes it's not worth it. And it's important to note that not all functional languages are pure. So Scala in particular, there's no restraint on side effects in any particular piece of code. There's a bias in the whole system toward immutability and purity, but it's just a bias. There's no enforcement, unlike Haskell, for instance, which makes life much more interesting. And of course, when you have static typing, there's fewer things to test, and there's many classes of runtime error that are impossible as long as no one's cheating by doing things like reflection and compiler bugs and so on. And when you have static typing, if it compiles, a lot of the time it's right. It's surprising, and it's kind of a bold claim, but in practice, it's actually true a lot of the time. When it compiles, it's correct. Immutable data, you can share it anytime you like. It's not possible to corrupt internal state. There's no need for defensive copying, and there's no time of check to time of use bugs. So for instance, you make a file descriptor, and the system says, okay, you can write to that file. And then somebody changes out from under you, and you start writing to it, and now you're writing to a different file that you weren't expecting. That's an old class of Unix security bug that sometimes happens again. And when the file descriptor itself is immutable, it can't happen anymore. It's not as inefficient as you think because you get structural sharing. So if you have a list of 1, 2, 3, and then you take the tail of it, that list of 2, 3 is the exact same data as the inner part of the list of 1, 2, 3. It's not a copy of it, it's a reference to it. And config management. Do it, it's good. So that was all about being proactive. But we all make mistakes. You can't always be proactive. Applications that are deployed routinely experience unforeseen conditions. You get noisy, the old man yells at cloud problems, right? Noisy neighbors, EBS decides to shit the bed, that kind of thing. And there's security problems. Things will go wrong, and you need to have visibility into what your system is doing and how it's feeling. So you need to do logging, and you need to collect metrics. There's a bunch of recommendations here that I don't need to go into. And here's a very short pitch in my second last slide. Do you have anybody whose job it is to watch the dashboards? You're lucky. Can you relate your logs to your metrics? Cool. What is normal behavior? Is what's normal today the same as what was normal last week or a month ago? I don't know. Can you write down your definition of normal behavior? I can't. How would you teach it to a human? How do you say, here's how you watch the dashboards and get good results and actually be aware when problems happen? What's a real problem, not a real problem? And how would you teach that knowledge of what normalcy is and what abnormalcy is to a system, right? How do you write a policy that describes the behavior of the system? Well, that's hard. And I have no solutions there except buy my software.
Thanks, Alex. I think that was definitely worth waiting for. Don't forget your laptop, though. It's over here.
Can I forget it? I don't really want it anymore.
And also, this is, I think, not our machine as well. Can we go down here, actually?
Oh, Sean asked if it could be up here so we could see.
All right. No,
it.
that's fine. That's fine. Thanks.
Oh, thank you.
Oh,
Give it a sec. You'll have to go back into full screen presentation mode. All right, so next up we have our Ignite session. As you remember how this works before, we've got 5 minutes worth of slides that rotate every 15 seconds.
cool. Also, slight change in schedule. Jerry Cotwell from Pulse is going last. Everyone else is as before.
Yeah.
Sure.
And can it, yeah.
Okay.
There's no volume control, so you just move it closer to your mouth.
Right.
That's how it works.
Cool.
So if you hear yourself echoing, just move it a little farther.
Sweet.
Okay.
Hey folks, my name is Julian Dunn. I'm from Chef. Hopefully this will advance to the next slide, which will be my first slide. There we go. So my talk is called DevOps Against Inhumanity. This was originally a full-length talk, so I'm going to have to talk pretty quickly. But you all know what Cards Against Humanity is? Pretty easy game, right? You've got a black card, and then you play the white cards, fill it in with the funniest thing that you can think of course. And my friend Bridget Cromhout, who's the co-organizer of DevOps Minneapolis, created a card game called DevOps Against Humanity. So again, same idea, but you can Google this. It's all open source, and you can print off your own cards at Kinko's and play with your friends and make your own black and white cards. So what am I talking about when I talk about DevOps Against Inhumanity? So who has been to a DevOps Days before here? Okay, so about a third of the room. And it seems like every DevOps Days we have this conversation about, who knows, there might even be talk today about this, but what is DevOps? What is the definition of DevOps? Are we talking about continuous delivery? Are we talking about culture, automation, measurement, sharing, empathy, cloud? And I guess my point is that trying to define DevOps is actually missing the point a little bit. My point is that my experiences working in technology is that the field is actually not a very nice place to work today. In addition to having these horrible cube farms, I've got a few examples for you about why I think that actually technology is a kind of an inhumane workplace today. So have you ever seen this sort of thing, right? A customer puts in a ticket and says, can you please do this project for me? right? Build me a new website. And haha, it's step one. Now there's an SLA, and now you have to do this thing, right, for me within 2 weeks. So I think we've kind of done this to ourselves. Also, being on call kind of sucks. This is also this is an example of what happens when Amazon nukes your HBase cluster, right, due to a bug. I call it the Vogels, actually. So you don't actually get a lot of sleep. And then there's software development, so more on the dev side, right? This cartoon's from 2005. I'll let you read it. Right? How many of you have been in that kind of a situation as a software developer? That's pretty horrible. And then also structurally how we set up our companies as well. So this is a customer of ours, which I'm obviously not going to mention because I'm using them as an example. But here's sort of main campus. You've got like beautiful buildings and some the water features and stuff like that, and a parkland, and that you can cruise around during your lunch hour. And then down here in this, like literally a converted computer factory, lightly converted, so the ceilings are very high, and it is literally cube farms as far as you can see. They aren't even near the main part of the business where business is done. So my point is, why do we do this to ourselves, right? Why do we continue to propagate this inhumane culture, and why do we continue to accept this as being like that's just the way we do things? Is it Stockholm syndrome? Is it just we're making good money? I think the idea where we want to go to in our lives is that we want to treat the work that we're doing as, we want to be proud of it, right? We want to treat our code and our software and our infrastructure as a craft, right? We're professionals, we're not just some ticket monkeys. So to me, DevOps really is just a declaration that we're going to stand together. All the groups in our company that work on technology are going to stand together against inhumane forces that are external to technology in our technology jobs. And why am I kind of bullish about this? Well, to me, every company today is moving online, right? Software is going to be the interface. So it started out with the web innovators, but even if you work in the enterprise, if you're selling insurance or whatever, even those companies are moving online. And if you're not actually able to do this, right, this is what's going to happen to you. And so I can make this joke because I'm in Canada. I'm actually Canadian originally, and when I made this joke to my friend, he's like, "That's exactly the problem with Canadian Tire, right? You can get from C to A to T, but then if you want anything, you have to go to Amazon." And of course, we actually know quite a bit about our companies, and Maslow's hierarchy of needs again. Everybody needs lolcats now before they need anything else, right? So that's why we're actually very important, and we actually know a lot more about our businesses. And if we're able to work together, we can actually shape the product and shape how our businesses work. Because, like I say, right? So you've got simple a banking company. It's not technology per se, right? But it's the way in which you're consuming banking services through software. And so DevOps really gives us a seat at the boardroom table. And what I mean by that is not only are you able to influence the product direction, but you're actually able to influence some of those cultural things in your company that maybe aren't even applicable just to your IT folks. That you can change. And so this is a picture of Chef's new office in Seattle, and you can see how we've kind of tried to solve this problem internally by just, you can see how close the CEO sits to engineering, right? So you don't have this line between the business have fancy offices and the engineers, have cubes off in a factory somewhere. So really my point is that, if we work together, we can not only influence our product direction, but the futures of our company and how they can survive with us as they go forward. So thank you very much.
You guys hear me okay? Yep. Awesome. So I'm here today to talk about Sparkle Formation, build your infrastructure, with CloudFormation, but keep your sanity. This is my first Ignite talk, so I'm very excited to be here. So who am I? So I'm Sean Porter. Many of you know me as Porter Tech. I'm the author of Sensu, an open source monitoring framework. I work at Heavy Water Ops, where we primarily do automation and monitoring and help people operate their infrastructure. So what is CloudFormation? Well, it's an AWS service that basically allows you to describe a collection of resources using a JSON template. It provisions those resources in an orderly and predictable fashion. So here's an example JSON template. So this is the hello world, if you will. It's what everyone expects when using it. They're like, oh, it's so clean, so pretty. Unfortunately, in reality, it's very different. What you end up with is 528 lines of JSON. right? So this is what you're gonna go in there, edit a parameter. Like, how do you digest that amount of information? It's not maintainable whatsoever. So, and like, how do you make multiple stacks, right? Well, I paste it, copy paste. I'll tune my parameter. I'll create another 500-line JSON blob, and I'll push that up, and I'll make my infrastructure. Yeah, that's just insane. So what are we working with? We're actually working with data, so hashes. And we can build these programmatically. So we just need enough DSL, not a full-out abstraction, just enough of a DSL, something that can merge those hashes. So we have Sparkle Formation. So it's a Ruby DSL that provides AWS intrinsic functions. So what's really cool is just because it's super lightweight, it's automatically compatible with future AWS resources. So the template anatomy, you get your parameters, which are essentially your prompts when you're building the stack, how many servers you're gonna have, resources, these are your things, EC2 instances, elastic load balancers. Then you have mapping, so a way of key values at runtime of the actual template. So you have a few functions. So you got your reference. This is what you use to be like, oh, that parameter I passed in, that's how many nodes I want. You get attributes. You can be like, oh, I need to call this key value, and join, you can concatenate strings. Your building blocks. You've got components, which are essentially static configuration. These are your common things like users that you need. Dynamics are basically argument-driven unique resources. So you can create things called like an ELB that takes a name and a config hash. So here's an example of a real CloudFormation or Sparkle Formation component. This one creates a CloudFormation user, and you can see it being used in a template. It loads the base and then overrides a set of parameters. So here's what that actually looks like. So instead of several hundred lines of JSON, you get essentially a function you can call with some arguments. It's a set of resources with the same set of defaults. So here it's actually in use. You can see in the middle there's the dynamic called ELB. We're going to name it website. In our auto-scaling group, we can reference it called website ELB. When instances come up in that, they're automatically registered as part of the ELB with all those default parameter settings. So the documentation, you can find Sparkle Formations docs. It'll do a better job of explaining all the components. But most importantly, the AWS docs for CloudFormation, since everything is basically camel case to underscore delimited. So for tooling, Sparkle Formation is just a library. So you need something to take that, translate it, and then push it up to CloudFormation. So you don't need Chef, but there's a Knife plugin for it. Here's an example of one that I use. So I'm creating a stack called Sensu42. It's using my Sensu Enterprise template. Processing means it's a Sparkle Formation. I want to transform it into a CloudFormation template. So what it's actually doing is that it prompts me for how many Rabbit nodes I need, Redis, Sensu, Chiwa nodes. And then it goes ahead and creates and uploads that template. So what's really cool about this is it actually takes it from there, uses Chef to provision those nodes, and essentially it's providing me my bootstrap orchestration. So again, hashes, that's what we're driving. It's data. We can programmatically create them. That's where the real power comes, and they're reusable components that bring sanity to trying to use CloudFormation. So thank you. Come find me and ask me questions.
Hey. Hi, my name is Omar. I'm going to talk about why I think we do too much work and run too many systems. I believe we should strive to ephemeralize as much as possible by offloading things that are not essential to our business to other services, especially while we're in the phase of building it up. The problem that I think is we love our jobs too much. We are busy building. We love our jobs too much. We love running systems and building them. We think our issues are special, but they really aren't. They're shared by many customers and many people, actually. To run a system, to build a system, building a system is hard. You need databases, you need queues, caches, everything. And you can normally pick those things off the shelf, like an open source solution, deploy it, and you're done, right? That's a pretty simple thing to do.
But the problem is keeping them running is actually way harder than installing them. Things break, they break all the time. There needs to be a way to handle database updates. Log pipelines will back up. Your build pipeline will crash. You will have raging like friends. Instances will crash and so on. And I don't want to mention security updates. Building your software is going to be hard enough. You shouldn't be focusing on all that other stuff. You'll be delivering features to your customers. And your customers will discover bugs. You'll be searching for that stupid error for a month, so you shouldn't be burning yourself out running a graphite cluster. We're already happy outsourcing a bunch of things to other services. We use Unbounce for our landing pages and MailChimp for whatever they do. We do communication at HipChat, and we let PagerDuty wake us up at night. Why are we not using Redis Cloud for our caching, Papertrail for our logging, Librato for our metrics, and that fancy pass for databases and applications? You should be focusing on your product, not on those things. Let somebody else do it. We have different excuses for not doing it. We talk about security and certification. We talk about latency and uptime requirements. This all comes down to being afraid. We're afraid to have somebody else run our core infrastructure because it's scary to do that. The thing is, wait for it. Like many of these components are already safe harbor compliant, HIPAA compliant, PCI compliant. Keep your sensitive information out of the logs. And if you don't know your latency requirements are not special. They're not unique. Take what you can get. I've talked about this for 2.5 minutes, but we need to step back a little bit because there are some worries. Services come and go. You might outgrow a service and need to switch them. You might discover a service sucks and you need to switch. So what do? Be aware of lock-in. Lock-in will happen. It's unavoidable. Understand it is more important. Think about how hard it's going to be to replace a service if you outgrow it. Does it do deployments? Fine. Is it a fancy proprietary API for accessing data using some black magic? That's not good. Understand your dependencies. Your services will go down. Those services, will go down. It's going to affect your uptime and it's going to suck. You're going to want to jump off it and be angry. Think about the big picture. How much work is it going to take to replace that component? Probably more. Think about your schedule, your priorities. Understand support. The service you are using is going to have to provide you with good support. You're going to be filing tickets. Do they have priority service? Do you need it? Do they have people on the page 24/7? Will they help you debug a problem you'll have? This is already important. Do they have a status page? Surprisingly enough, not all do. Things will fail. Don't expect 100% uptime. Accept failure. Your service might be slow for a second when they're fixing an instance. Be happy you're not the one fixing the instance. Go refresh the status page and be angry on Twitter. Understand that the service is a live target. They are always updating. They will force you to upgrade. Embrace it. It's good that they're forcing you to upgrade. They will deprecate APIs. It's better not to be stuck on Postgres 9.4 for the next 10 years. Go with the flow. So yeah, getting there. Important to design your software around this thing. Design it in a way that lends itself to this environment. I'm going to go into that a little bit more in a second. There will be trade-offs. It's going to be hard. It's worth it, though. Building for it. Follow a pattern. I'm going to say 12 factor because it's a good word. It'll restrict your options. It's going to be painful, but it's useful. You can move to different services if you follow a pattern like this, and you can focus more on your product. You're going to have to bite the bullet, but it's worth it. Abstract them away. What I mean by this is, as I said, your service provider will change their APIs, so be ready with those things in a different place in your code so that you can follow along. Also, you might discover they suck. You might outgrow them. Again, it's easier to switch providers if this is handled separately in your code. Now, why listen to me? I've made these mistakes. I've spent a Saturday evening installing Graphite because I didn't want to spend $25 on Librato. And instead of delivering actual features and stuff, don't do that. So takeaways, if you can use, next time you need a service, think about not deploying it yourself, but look at the options around you and make your life slightly easier. So let's try to ephemeralize as much as possible. Thank you. I'll find my way down somehow.
Okay, let's see. Yes, working. Good. Yeah, so really excited to be here today to give a little 5-minute talk. I guess an interesting thing for me is when I submitted this talk, I actually, 15 seconds is awkwardly long. Do I have to actually hit go on this? No? Oh, yeah. So when I actually submitted this talk, I submitted it as an hour-long talk. And they're like, surprise, John, you're doing an Ignite talk instead. So really excited about that. Changed things up a little bit. What I want to talk about today is actually getting away from some of the hypothetical situations. I want to talk about some really practical things. Actually, 3 really weird tricks that you can use to return to the office on Monday and have better production uptime, better handling outages. So actually, it's a few different things that we've already talked about a bit here today. So the first thing is chat ops. How many of you have been in a firefighting situation and that hero, Luke Skywalker, whatever, jumps out and he's like, I got it, don't worry, goes into a cave for a while, log SSHs into a server, runs a bunch of mystical commands, comes back, says it's fixed. Next time the outage happened, Luke happens to be like away in the Dagobah system or something, and you actually need to fix the issue yourself. You have no idea how to do it because there's no record of what he did. What ChatOps is all about is hopping into a channel, a battle bridge, and talking out, writing out what you're doing. Turns out chatting is really fun, so it's actually kind of cool. Just write, hey, what I'm doing is I'm SSHing into this server, I'm restarting these services. Next time that issue happens, someone else can recreate your steps. It's really cool. If you don't have a channel for dealing with outages, you should create one. Hubot is this cool chat robot that can also help mark those kind of outages and stuff. We love them at Mobify. 15 seconds is such awkward timing. So second thing, stole it from PagerDuty. It's this concept called Failure Friday. A lot of times you'll have new members on your team who happen to be the only people who are present when that production outage hits. Hey, new guy, can you fix that thing on prod? They have no idea what to do. So the way to kind of train them up is to actually put them in those scenarios before they happen. So introduce the failure into your services yourself. So obviously, you don't want to necessarily start with production here. Hopefully you have a staging, maybe a QA environment that mimics your production environment. And what you can do is just go in there and think about your different services as kind of like a cut the rope or Fruit Ninja game and just chop that connection link between your 2 data centers, between your application server and your database, and see how your system reacts. Get your new folks to diagnose the issue. What kind of notifications did they get? What kind of warnings did they get about how that service was about to fail? And then walk them through fixing it. Walk them through fixing it in the battle bridge so you have a record of what happened. Something that's cool that we've been talking about that goes along with this is these postmortems. So a lot of time after an incident, there's this like rush to a solution. I've got 5 ways that we can avoid this problem next time it happens. But what people don't do is go back and actually think about what were the decisions, what were the actions that happened along the way that got us to where we are? What notifications did we get? What information did we get from our systems that could help us do, I guess, better next time? So one thing we like to do is go in and actually create a big log. What happened? Actually, Etsy's got a really good blog post on blameless postmortems. Take a look at that. But essentially, the first thing that we do at Mobify is we go back and we actually write this really long Google Doc of exactly what people did and when it happened. That battle bridge is really cool because it has those timestamp chat logs of when different things happened. And if you have Hubot sending messages in there, then you don't need to go back and recreate that paper trail from scratch. After you've got all those things, you can take a look and kind of decide what to do. Now, changing process really quick. So that's 1, 2, 3 things that you can go and try on Monday. One thing I'd say is when you look at changing process, I look at it a lot like changing code. There's this idea that, hey, we got to change everything to fix what we're doing because everything that we're doing is wrong. When you're changing code, it's good to make small iterative changes, right? Because then you know how the system is changing, and if it doesn't work, you can roll that change back. Think of using the same strategy for changing your process. What you can do is take small wins and use them to build momentum into crushing big, thorny issues. So don't change everything at once. If you could take one of these 3 things and get buy-in from your team to using it, maybe you can rule out the next thing later. So yeah, that is 3 super awesome things that you can do starting on Monday. So just to review really quick, if you're not already doing them, chat ops, what's the second one? Something else. Postmortems and Failure Fridays. Yes, Failure Fridays. So if you guys want to chat about any of those 3 things, I'll be hanging around afterwards. Thanks so much. Appreciate it.
Mic check. I'm ready. Oh, there we are. I'm a computational biologist by training, and I've spent the last 14 months at Joint working on this problem, which is dealing with the piles of JSON that they had lying all over the place and trying to build a data warehouse out of that. And Stack Overflow is crickets on this issue. So if you want to convert JSON into a data warehouse, you can take the blue pill and choose a no SQL solution, and you're done. Or you can dive deep into the rabbit hole of SQL normalization. And that is a rabbit hole that looks like this with all the normal formalization and star schema. And this is like a splinter in your mind, driving you mad. A prison for your mind is how we consider schema. And so how do we get schema from JSON? Well, here's JSON as the matrix. There's a couple of very simple examples of JSON, tags and values. We spread them out into a matrix with tag names at the top for columns and values. You can see that, wow, some of those are repetitive. I say a lot of dollar signs, but that doesn't mean a lot of money. But those are repetitive edge cases of columns. And the other case you get in JSON is sparse edges. And so if data behaves according to a power law, we can think of a different way to make a schema, which I call the power schema, which takes the two edge cases and tables them out. The sparse table, those rare key value pieces of information in your JSON get put into a key value store in that little table at the top, which means that you can add anything you want to this later. It retains the agility that you wanted. The main table gets all the data that varies a lot. The SQL typed columns I'll talk about in a bit, and JSON B columns. You can actually put subsets of JSON into different columns. And the repetitive table, all the data that has version number that repeats itself millions of times. Those can all be condensed into a hash lookup, made unique, and this literally compresses the data set down to a point where you get the matrix reloaded. So the power schema looks at the properties of data, not the properties of relational algebra. And so you have a sparse table, a main table, a table. So how do you figure out which columns go where? There's a very simple set of information theory-based metrics. You measure the uniqueness, the number of defined entities, the number of missing entities in a column. You do a little bit of math. The hardest thing is doing a log base 2 of the information. That forms a very simple scoring function. When that score is greater than 0, you get the main table, and when it's less than 0, you partition into sparse or repetitive. So this is really simple. You can do it in a spreadsheet. You can do it in a little piece of R, and you end up with categorizations on the far side of the main table, the repetitive table, and the sparse table. So this can be done on a sample of JSON data, about 10% of your whole set. Now, how do we build this? So what I've used is Postgres 9.4, the beta, which introduces the JSON B data type, and it makes each SQL column behave like a NoSQL JSON document store. Each column can be a NoSQL document store. And so you can jam everything into one column and be done with it, and that's the blue pill solution. The red pill solution is to use the type casting and that strong type inferences inside Postgres, because if you don't, problems will arise, and I've seen those problems. So I built a repo with a column type detection system. So it uses a streaming decision tree and a meta finite state machine, which goes through all of the lines of JSON and collects and aggregates the information to detect the types. And all those types are detected in the repo, and arrays of all of the above. So arrays of IP addresses, timestamps. These get converted later on into strict PostgreSQL types, because they're not strict in JSON. So the steps to this are to take your JSON, classify it using that little bit of mathematics, split into the tables, and to detect the types using the streaming processor in each table and each column, and then output a tab-separated value file, which rearranges the JSON into something that the PostgreSQL loader can load very quickly. It has a fast parser, but it has sticky column type rules. And that type detector that I talked about provides that TSV translation for you and matches those rules. So to load that in, it's a copy table. The schema is automatically generated. You then can query with SQL and JSON B operators, connect Tableau, R, ODBC, and your JSON data is in an SQL format. So that's the repo. I'm at CWV Hogue. Thank you.
Can everyone hear me?
What's that? Well, hi, I'm Jerry Cattell. I work at Pulse Energy here in Pulse is located here in Vancouver. I actually work for them remotely in Chicago. I'm very involved in the DevOps community there. I'm one of the organizers for DevOps Chicago and for the meetup group. And most recently, I was one of the organizers for DevOps Days Chicago last month. So, you know, it's hard starting one of these conferences. And one of the things that we thought was very important is to have diversity. And originally we were like, you know, we want diversity like Chicago has. The tech world in Chicago does not match this at all. But we still thought diversity was really important. And you might wonder, why is diversity important? And really, all these DevOps things, you hear about empathy, you hear about inclusiveness, and we include groups like, you know, development, operations, QA, InfoSec, all these groups. It's important to include them. But it's also important to include people regardless of gender, race, whether age, their socioeconomic background. These are all very important things. And if the touchy-feely part isn't enough to convince you, then there are also lots of studies that basically show you that teams that have more diversity make better decisions. They perform better. So there's actual science to back it up that we should have diversity at these conferences because we'll learn more from each other. Now, I looked at the diversity from past conferences, limiting it to North America. And you'll see it wasn't very good. Until pretty much this year, there wasn't a lot of women. And I use women only because that's the easiest one to actually track, looking at speakers and stuff like that. Attendance is something that you can't really get. At this point, I have to say thank you to DevOps Days Minneapolis and Bridget Cromount, who was mentioned before. She helped us tremendously on our conference, and we would never even have gotten as close as we did with our numbers if not for her. We borrowed liberally from DevOps Days Minneapolis in terms of their code of conduct. And I mean, we did this well. We made sure people were aware of it. Much like here, we announced the first thing. And this was important. But when it came to like actually looking for speakers, this is about as far as we got on trying to recruit women. We all tweeted out to our networks. We put it on LinkedIn. We put it on Facebook, all that type of stuff. But when we looked at our results, this is kind of what we got back for proposals. So we started scrambling. I mean, we had about a week left to try and get our speakers in place. And so we started to reach out to lots of local groups, like Chicago Women Developers, Women Who Code, Blacks in Technology, IC Stars, which does inner city, works with inner city people. And we didn't get much back from them. We did luckily reach out to a few people who were willing to, who we specifically asked to speak, and they came and did a great job. So this is probably why we didn't get a lot of responses from that. Fletcher, if you have a picture, I think myself, who's hidden there, and Shannon are looking at your camera. So, but even though we didn't get very far with speakers, these groups all came through very well in actually getting women and other minorities to actually attend the event. We were able to sponsor it, and they provided it. And the question was kind of like, why were those the ones that came through? And it turned out each one of those had a personal relationship with one of the organizers. So they sort of trusted us, they knew how it worked, and they were willing to say, yes, we'll send people. So that got me thinking about my personal network. And when I looked at it, early in life, I had a pretty diverse background, but then since I've been working in the tech world, it's sort of changed. And this was sort of like who I followed on Twitter. So since then, I was like, okay, I need to diversify myself, my own network. And I started basically following lots of women on Twitter and other minorities. But no, you start with just a few, and really, it leads to, you find lots of more new interesting things that you did not know about in the tech world. So we already started thinking about DevOps Days Chicago 2015, and we're like, what can we do differently? So we're starting by actually going to these groups, and we're going to try and do workshops with them. We're going to try and get some people in there to speak at DevOps Chicago Meetup, and really get them integrated into the community more than they have been in the past. And hopefully get an actual organizer from some of those groups to participate. So I do want to
congratulate DevOps Days Vancouver on having a great speaker lineup. They did a fantastic job. And here are some people to start following on Twitter that will at least get you started learning more. And just if you have any suggestions, I would love to hear them. Thank you.
All right, thanks to all our Ignite speakers. That was really fantastic. And we're going to cycle here, apparently. So it's all right. I can't stop it. It's impossible. Anyway, so if you could come back up, and we're going to give that a second time in case you missed it. No, I'm kidding. So we're going to take a break for lunch. We're a little bit over time at this point because we had those technical issues in the middle. I just get a quick show of hands here. We can go the full hour at lunch and push push all of our stuff back 15 minutes. Who wants to do this? Everything 15 minutes. Who wants to start after 45 minutes of lunch? Okay. Who doesn't care? Okay. All right. So I'm just going to push everything back 15 minutes. I think that it's not a big deal, and I want you to be able to eat as much as possible because we have a lot of great food out there.